Hello and welcome to another Zozi session. How about that? How about that? I bet you didn't expect that shit to happen. So, on the previous stream, we explored a simple video format. And we came to the conclusion that it's not really suitable for my needs. But I still didn't have enough time to actually explore everything that I wanted to explore with this format. So, and I really didn't want to make the second session on this topic, because usually the second episode of any series, nobody gives a shit about them, right? So everyone just only watches the first episode, and the rest of the series is just like, you know, nobody gives a shit about that. But still, I wanted to do that, at least for myself, right? At least for myself, I wanted to explore the you know, the other things we can do in here. Specifically, I wanted to generate more than just like a solid color. Yeah, let's just go ahead and do that. So let me switch to a different scene, right? Switch to a different scene. And so we have a bit of stuff, right? So we have a bit of stuff that can generate a particular video. So first thing I probably would like to do is maybe write some sort of like indication of the progress, because it takes some time to generate a video, right? So, and yeah, so if you take a look at the video itself, so here is just a solid color. Like, I would like to have something more than a solid color, maybe animation of a rectangle that is moving around in the video or something like that. And furthermore, I would like to try to even generate a sound for the video, right? Even though I think this format does not really support the sound, right? It doesn't really support the sound. I still want to do that like in a separate file. Right, I'm going to be using the PCM format, the one that I used in my, you know, music with Haskell video. So you can find that thing in the description. So just a second, I need to load up all of my applications. So then I'm going to go to the description. And also in the description, I'm going to give the link to the previous episode, right? Previous episode. So the previous episode is not out yet, so it's going to be available after the stream. So I'm going to put TBD in here, just a reminder for myself. And turning music in Haskell. Music in Haskell. So I think that's the thing that I wanted to give you, right? So that's the link. Music in Haskell video. There we go. So you can find it in here. So for those people who's in the chat, you can find this thing in here. All right. So yeah, and let's go ahead and just try to do something, right? I'm gonna just restart Emacs from within my development environment, and let's see. So things I want to do right now, just let's actually start it to do. Upload the code to GitHub, right? So because I never uploaded this code to GitHub, so it's not available to anyone, right? So another thing I want to be able to do, indicate the progress of the rendering, right? Because it's not really convenient when the program just stalls for a couple of seconds and maybe potentially even minutes, right, without any indication that something is happening, right? So it would be nice to have some sort of this thing like that. So indicate the progress of the rendering, and another thing would be to like animate something, right? Animate something, some sort of like a rectangle or square or something like that, and generate sound in PCM format in a separate file. Maybe even try to merge it with the video file using FFmpeg, something like that, right? So let's see if we can even do that. So after that, do I want to have anything else? I think that's basically the whole agenda for today's stream, right? So upload all of that to GitHub, indicate the progress of the rendering, animate something like a square bouncing off of the, which one, bouncing off of the walls of the screen or something like that, right? So, and generate sound in PCM format. So maybe the sound is going to be like generated when the square like bounces off the wall, right? So it just will make some sort of like a quick sine wave beep or something like that, and we'll see how it goes. We'll see how it goes. So that's going to be basically the idea. So I want to do all of these exercises. It's more of a like exercises to get the gist of the format, and just like, you know, see this format in more use cases, right? So this is something that I wanted to do yesterday, but I just didn't have enough time for various of reasons. So okay, so what do we have in here? So this is the formula. I already coded that formula into the source code itself. It's a formula that converts I think RGB to YCRCB, so it's already coded in here, so I probably don't need this image anyway, right? So fuck this image. So here's the main executable in here, so I think we can straight up git ignore that executable, so this executable is not going to be committed whatsoever. So here's the main source code. We're going to be using a single file, a single Rust file, and since we're not using any dependencies, I don't see any need for cargo. So I think you need complicated build system and package management if your project is basically a bunch of duct tape dependencies, right? But if you're developing something from scratch that is self-contained, there is not much need for any complicated process or any complicated package management or anything like that, right? If you're just writing the code that does a thing, you don't really need anything. You just need a compiler that translates that code to the machine instructions so you can run this thing on a CPU, right? So it just makes sense. So pure programming, as I like to call it, a pure programming. Okay, so another thing we have in here is a PDF file, which is like a weird documentation from where I stole the formula, so I'm gonna just straight up remove that. So we have a bunch of samples in here, and these are the samples from the website where we found the description of the format, right? From the app site where we found the description of this format. And I don't know, do I want to include these samples in the original repo? Do I want to include them? I'm not quite sure, because I'm not sure if they're that useful, right? I'm not sure if they're useful, so maybe I'm not going to include them. But at the same time, I don't want to remove them either, because they're kind of useful. To be fair, they're not really that useful. Right, so let's actually go ahead and remove that, because we explored everything we wanted to explore with the samples, so we don't really need any samples because we're generating everything ourselves. Right, so there's a couple of garbage in here, so this is just a, you know, leftovers from ppm generation, and here is the video file that we generated, and I think we're gonna just basically git ignore this file. Y4m, and there we go. So far we have only two files that we really want to commit in here. It's a main.rs and .gitignore. I don't want to commit to do, because it's just like a local file that I'm going to keep around and I'm going to remove at the end of the stream. So I'm going to create a readme. First of all, we need to release this entire thing under a particular license. I like to prefer to use MIT license. So then we're going to do readme, and here we're going to put the name of the project, right? So it's going to be 2mpeg4yuv, right? So that's basically the name of the project. So simple playground project to explore the UE4mpeg2. What was the name of the project? Like simple video format. Simple video format. Simple video format, and so UV4mpeg2. Okay, so UV4mpeg. So I'm gonna give the link to this format here in the description. Right, so we're gonna have a quick start. Install the Rust compiler, right? So we're gonna give the link to the Rust. So you can find it in here, and so I'm gonna just copy paste this thing in here, and here is the console. We're gonna do rust c main.rs, then you just run main, and then you open the output file in using you know, mplayer, right? So yeah, it's actually maybe any player that supports this kind of format. Oh, I wonder how many players support this kind of things. So does VLC support this stuff? I wonder. So let's try to open it with VLC. VLC support that, but it's actually a different color. And if I open that stuff in mplayer, Is it possible to upload this file to, for instance, Discord? It's probably too big. Yeah, it's probably not going to be recognized as a file, as a video file. So it's processing it. Nah, it didn't recognize it properly. Okay, so maybe yeah, you know how there is like all of these memes about, oh, this video file crashes Discord. I thought maybe you can do something similar in here, but it's actually really funny. So we discovered something new. So depending on the video player, you can actually, yeah, the video player will display it differently. This is so funny. Okay, so what if I open it in the Chromium? That's a very sad Russian noises, I suppose. Okay. So do I have something like some other things like MPV? I think I do have it. So let's actually open it in MPV. All right. So at least 2 out of 3 video players displayed as red, and only M player displayed as blue. Which is kind of sus, not gonna lie, but interesting nonetheless. It is in fact interesting nonetheless. Maybe this is something that we can explore at some point. All right, so let me create a repo, git init, right, and let's do a committee, and maybe even pushy. And maybe even pushy. Maybe even pushy. Ready, set, go. And where is this shit? Okay, so oh, you already managed to download this file. Okay. That's kind of interesting. So I'm gonna be uploading the repo soon, so anyone could generate it. 2mpeg4yuv. All right, it's 2mpeg4yuv, and I'm gonna just do public. Okay, and I'm going to just do add origin, and just do this kind of thing and push. Okay, so it's taking some time. I hope it's gonna be working. I hope it's gonna be twerking. So, okay, so yeah, the source code from the yesterday stream is available in here, so go grab it if you want to. So here is the source code, and I'm gonna also add this entire thing in the description, right? So the source code of 2mpeg4yuv. There we go. 2mpeg4yuv. So main.rs. Yeah, there we go. So here's the source code. So as you can see, it's a pretty readable source code. Anyone can modify it. It's really approachable. Very cool. Really recommend it. So I'm not even sure if we need anything related to ppm, as you can see, right? So, it's kind of strange, but anyway. So to do, I'm gonna go ahead and just mark this entire thing as done. Upload the code to GitHub is done. Now we need to indicate the progress, right? So we need to indicate the progress somehow. The indication of the progress should be relatively straightforward. It's basically like we're rendering the frames. We know how many frames we have, and we know what current frame we are rendering. So essentially what we can do, we can take a frame, convert it to F32 and divide it by frames count, as F32, and we get a percentage, so we get something like progress, right? We get something like progress, and then we can just simply print this entire thing, progress, something like this, and this is the percentage, So, and this progress, if multiplied by 100, is going to give you the percentage. So let's see if it's gonna work. If it's gonna work now, yo. So I'm gonna recompile rust c main.rs. So it takes some time. I wish the compiler itself would indicate the progress of the compilation, but it doesn't. So we have this thing. Okay, so this is unused. So pixels are unused right now. So maybe we can remove this thing then. So what else do we have in here? Different kind of pattern. So different kind of pattern probably is not needed anymore. So I'm going to be removing this stuff. So function is never used, which is, there's a lot of shit that is not used in here. So let's actually not fixate on that, right? So let's just not fixate on that for now, because right now we're doing the progress, right? So I'm going to do rust main.rs, because we never know what's going to be needed and what's not going to be needed. So it's kind of, oh, there we go. So we're generating the thing. It would be also nice to maybe round it to some sort of a value. I don't know, floor it. Or maybe straight up round it, who knows. Rust stdlib. stdlib. So, do you have round in your standard library in 2020? Well, you do have round. Would you look at that? That's amazing. Right. Round in 2021, and maybe that's precisely what I want to use in here. Okay. So after that we're going to be just multiplying this by 100, and then I want to round this entire thing, and maybe I want to translate this stuff to just I don't know, usize, right? And then you can say the progress. Right? So this is just a percentage, a simple percentage. There we go, and that didn't work because I didn't recompile. I'm not gonna succeed in the game development industry if I don't recompile. So it's cool and all, but it would be also cooler if every time we're about to bust, to print the progress, we would do like a caret return or something, if you know what I'm talking about. Right. So it would be kind of POUG, but I'm not sure how to do that. How are we gonna be doing like the return? So maybe we're gonna like not print the new line, right? Not print the new line and always print /r, if you know what I'm talking about, right? So will that do anything for us? I think Emacs is incapable of actually generating all of this. Yeah, that was weird actually. So it does not even display that. You know why? Because the output in Rust is probably buffered, right? It is probably buffered, and we probably need to flush every time we like print the progress and whatnot. So how can I flush std out? So maybe there is something in the standard library, so something like flush, if you know what I'm talking about. So, but the question is, how can I flush std.io? Right, so we need to be able to just do std.io, std out specifically. So there's some function to get std out, but this is just a function that gives you this like weird struct. It's a handle to global thingy, and does this handle implement write? Right, because I know that write is the one that can flush things. Okay, so that means you can probably do something like io std out and then flush. And does flush fail? Yeah, it does fail, so that means I can put things like that. Can I? Maybe not, maybe it doesn't matter. Okay, so let's actually see if it's gonna work. If it's gonna work now, yo, I'm gonna recompile this entire thing, and I'm gonna run this entire, and there we go, so we have a progress. How about that? So, I was right. 15 years of software development were not for nothing. Right, so I basically know this problem by heart, right? And I just went and found the solution. Isn't that cool? Probably not, because otherwise I would have been employed. Anyway, So here's the progress, which is kind of cool. Maybe we can even increase the duration, right? Maybe we can increase the duration. Let's actually see how it looks like in Emacs. Emacs can actually also, you know, display that, which is kind of cool. Progress. Okay, cool. So, I think we finished this entire thing, and we are ready to do a committee. Implement indication of the progress. Right, implement the indication of the progress. I'm going to push that right into the repo. Right, pushing that right into the repo. So let me see what's going to be the next thing. So animate something. Right, so the time has come to finally animate something. What we're going to be animating, right? As I already said, I want to animate like some sort of a rectangle. Right. So I'm going to move all of these things to a global thing. So width and height is going to be the size of the canvas for which we're rendering things, right? So an FPS also going to be part of the stuff. Duration, I'm not even sure if duration is going to be in seconds, but maybe it will be in seconds. Why not? Yeah, I think this sort of constant is nice to have anyway. So it should be fine, I guess. Okay. So I need to be able to, yeah, I want to render things in RGB, right? I want to render things in RGB, and I also want to render things in a like a tightly packed manner, right? Not in a planar order. We already learned what is a planar order in the previous stream, yeah, I want to be able to render things in a more natural way, for me at least, right? For me, the most natural way is, you know, just a canvas of tightly packed pixels and the RGB, right? So, and I think I need to be able to distinguish these kind of things, right? I need to be able to distinguish this stuff, but I'm not sure. Oh man, so what's gonna be the easiest way to distinguish all of that? So because one of the things you can probably do is maybe have a type for something like RGB 32, right? And this one is going to be U32, and then every time you mean the like some sort of a canvas that is RGB 32, you would say that it's a slice of RGB 32, right? It's a slice of RGB 32. So, but the YCBR are not that. They're like, you know, separate planes and whatnot. So it's not gonna really work well. It's not gonna really work well. So I don't know, maybe I should not fixate on that, because every time I try to fixate on these kind of like things, I get nothing done. So let's just like code. Let's just write code, and then the pattern will emerge, hopefully. The pattern will emerge, hopefully, and we'll be able to extract things out, right? So the thing I want to be able to do right now is, given the canvas, right, given some sort of a canvas, which is mutable because we're going to be writing into that canvas. And probably the stride of the canvas, right? So canvas stride is going to be usize. Given the canvas, and maybe the position of the position within the canvas, right? And the size, draw a rectangle of a particular color, right? So maybe we can have something like a rect position, and the rect position should be what? Yeah, let's actually pack that into like a pair, right? So this is the position, and the rect size, which is going to be like this sort of thing, right? There we go. So rect position and rect size. And also we need to specify the color, right? So we need to specify the color that we're filling in here. So that's basically going to be the signature of this entire thing. I don't know, so it's, yeah, something like this. To be fair, maybe we can compress the rectangle and actually make it like a, you know, something like this, right? And just get rid of the rect size. Get rid of the rect size. So you have a canvas stride, you have a rectangle that you want to fill in. To be fair, maybe we can allow the rectangle positions to be negative, right? But I don't think it makes sense to allow the rectangle size to be negative. I don't think I want to deal with that. So this is going to be our rectangle, right? So that makes sense to me. And then the color is just like a pixel. All right. So let's call this something like fill rect, but we need to indicate that we're talking about RGB, right? We're specifically talking about RGB. But maybe, yeah, maybe we don't even have to worry about that because we're only going to be converting to YCRCB when we're saving things into a particular file. So maybe because of that, I don't have to really worry about that. But I'm going to put RGB anyway, right? So just fill rect RGB. There we go. That should be fine. That should be fine. That should be fine. Does anyone have any questions about what's going on the screen right now? Okay. So let's go ahead and compute the size of the canvas. So the size of the canvas stride is basically the width of the canvas, right? So it's going to be something like canvas stride, right? Canvas stride. And height is going to be canvas canvas length divided by the width, right? So this is going to be like width and height. So this one is going to be very useful in the future. So for the rectangle, I need to think how we're going to be approaching all of that. So I suppose I'm going to be just iterating the rectangle row by row. So this is going to be in 0 up to... I want to actually destructurize this entire thing somehow because it's not going to be particularly useful. So I'm going to take this stuff and this one is going to be in Rx, Ry, R width, R height, and then I just do rect. There we go. So, and then we do RH, 0, R width. There we go. But this is more of a like a delta. It's not an absolute value, right? So it's not really absolute value by any stretch of the imagination. So, and then we need to take the position at which we want to do that, our x, and add dx. So our x is I32 and dx is in fact is U32. So I need to convert it to I32. So x is going to be I32 as well, right? And then this is the same thing is going to be for the y. We need to check that x and y actually lie within the canvas, right? We need to do the boundary check stuff. So, and to do the boundary check stuff on I32, I suppose I will have to actually convert this entire things to I32 and this entire thing to I32 as well. So we're going to be doing all of the computations within the I32. Right, okay, so if, let's say, from the range from 0 to width contains the x and the range within this stuff contains the y, we know that the current pixel that we're currently handling lies within the canvas, so we can go ahead and fill it in. So I'm going to do canvas. So we'll have to convert x and y finally to usize, but I think I'm going to do that in place. So it's going to be as usize, right? So this is going to be as usize multiplied by canvas stride plus x as usize. There we go. And we're filling in the color like this. There we go. So we managed to write a function that given the canvas and a rectangle, fills that rectangle within the canvas with the specific color, right? So yes, so we have that, and we can use that finally to generate the things. So now I probably need to generate the canvas, like memory for the canvas, and constantly update it and stuff like that. But as I constantly update the canvas, I think I need a way to clean the canvas, but maybe I don't have to clean it. So the only reason why I need to clean the canvas is that when I put the rectangle on it, right, when I put the rectangle on it, I need to clean everything and put it in a different place. But since I only have the rectangle, I can actually call the fill rect twice. Basically fill it with a contrasting color, with the foreground color, save the frame, and fill it again with the background color, and then place it in a different place. So it's actually a very old trick that used in old computing to save on the CPU counts or whatever the fuck it is. So you don't have to like traverse the entire thing, right? Because the video memory is slow or something. But the reason why I'm using it here is because I'm too lazy to implement yet another function. Though I could have just used the same function and setting the rect to the size of the whole canvas. Well, I mean, so probably one single function is enough for everyone. All right. Anyways. So we have frame counts. Pixels is probably the canvas. So maybe I'm gonna go ahead and rename this thing to just canvas. So output file path, I'm not sure if output file path has to be this sort of thing. Maybe I'm gonna actually put this thing into the constant, right? So this is gonna be the constants, output file path, which is gonna be str, right? So this is basically what we're going to have in here. Right, and then I'm gonna be doing it like this, right? So we're opening the sink into which we're like dumping everything. We're dumping the metadata, and we sort of like start simulation, I suppose, right? We're starting the simulation. So to do the simulation, you always need something like delta time, I suppose, right? You need something like delta time. Alright, so, and we can easily compute delta time by knowing the FPS, right? So we're gonna do something like delta time, which is probably gonna be float, right? Because it's easier to do animations with a floating point delta time, which represents the seconds, right? So we're gonna take the floating point 1, we're gonna divide it by FPS and convert it to F32, right? There we go. So here's the delta time. Cool. Now, so what we're gonna be doing in here? So I suppose I need to remove all of this shit, right? So this shit is not really needed. So here we're indicating the progress and whatnot, and here is the first frame. So we need to keep track of the position of the rectangle, right? The current position. So let's actually call it something like rect x, right, which is going to be, I suppose, I32, and initially it's going to be 0, so it's going to start at, you know, 0, 0, so x, y. So the width and height, I'm not even sure what's going to be the width and height. Maybe we're going to put width and height somewhere here. So this is going to be rect width, and I don't know, let's make it like 50, right? Maybe 50 and 60, right? 50 and 60. We're gonna make it 50 and 60. Sorry, I'm really new to Rust. I wonder why does main need to return iResult. It doesn't need to return. You can remove that and it will work fine. So it's just like, it doesn't need that. It's more of a preference thing, right? So yeah. The whole language is basically preference anyway, so don't really stress about it too much. Okay. So what I was doing, I forgot what I was doing. So I was trying to draw a rectangle, right? I was trying to draw a rectangle. But I still need to fill the canvas with some sort of a background color, right? So maybe as the first thing, what we're gonna do in here is essentially, before rendering anything, right? So I'm gonna take the canvas, right? So this is the mutable canvas. The stride is going to be width, and then I'm gonna start at 0, 0. And width and height is going to be literally width and height, and the color is going to be, I suppose, background, right? So we're going to have a separate color for the background. The question is, what's going to be the background? What's going to be the background? So for a background, I kind of like this color, which is 80, 80, 80. That's basically the background of my old color theme in Emacs, and I kind of like to do that. So const foreground. What's going to be the foreground? It's going to be U32, and let's put it like, I don't know, let's make it red, some sort of like a reddish color. So it's going to be background and foreground. Right, so we fill the initial thing like that, right? So this is the initial thing. And now what we want to do for the first frame or something like that, we want to fill that rectangle yet again. So canvas, this is the stride, and we're going to be using rect X and rect Y. And then we're going to have a rect width and rect height. Right, there we go. And the color we're filling all that with is the foreground. Right, there we go. So we filled that rectangle. The next thing we need to do, we need to save the canvas as the YCRCB frame. Right, that's what we need to do in here. YCRCB frame. But this is going to be rather interesting. So it would be nice to have a function, right, that accepts the canvas, right, accepts actually canvas as an immutable thing, so U32, and the canvas stride, right, so here's the canvas stride. So, and of course it's going to accept the sync into which you are saving this entire stuff, so we're going to take a mutable implementation of write, right, because we're writing into this entire thing. And it's going to save it as YCRCB frame, right, so, and here we're going to return IO result, like this, there we go. So how are we going to call this function? I think I want to call it like a save canvas as frame, right, and I think that in fact makes sense. Save canvas as frame. So to save a thing as a frame, we need to write first an indication, right? Indication that we're rendering the frame, right? There we go. We're rendering the frame, and next we need to save YCRCB planes. Right, but we need to convert this entire thing into YCRCB planes. So we need some sort of a function, right, that accepts the canvas like this, 132, and of course the stride, because without the stride we cannot even you know, determine the size of the canvas, the dimensions of the canvas, right? And it should return us, I don't know, maybe like three vectors, so like this, vec u32, vec u32, and each of them is going to be like Y, CR, and CB planes that you can save to the file. Actually, it's not u32, it's actually u8, right? Something like this. So, and yeah, it's basically that. It's basically that. So, but maybe it would be better to have like a structure that stores these planes, right? If you know what I'm talking about. So maybe we can just call it something like struct YCRCB, and we can indicate the format of this thing, right? So we can indicate that it's a 444, right? And then this thing is going to be like a Y plane, vector U8, right? Then you're going to have CR plane and CB plane, right? And here this entire thing is going to just return YCRCB 444, right? So it's just basically a bunch of planes. Right, and then we can say something like canvas as YCRCB444. There we go. So yeah, basically something like this. And then once we've got those planes, we'll be able to just simply save them, right? So I can do something like YCRCB444 and then canvas as YCRCB444. I'm going to provide the canvas stride, and then I will just save all of these things as continuous bytes. So I should be able to just do write, maybe even sync write YCRCB444 Y plane, right? So this is going to be Y plane. Then maybe I have to even reference this entire stuff. So then CR plane and then CB plane. There we go. So that's basically what we can have in here. And this thing is not implemented yet, of course, so it's going to be just something to like to do. So this particular organization of the code is not the best way to do this kind of stuff, I think, because it constantly maybe recreates the object, so it creates a new one and then destroys it, creates it and destroys it. It would be better if this kind of thing didn't really return YCRCB, right? It didn't really return it, but rather so you had an output that is passed as immutable, right? And then you would basically allocate only 3 vectors in here, right? You allocate in only 3 vectors and you constantly reuse these vectors, right? Because they pre-allocate, they stretch up until a particular point, and if you clean the vector and start pushing into the vector again, it doesn't really reallocate the memory until the capacity is sort of like exceeded. So maybe it would be nice to just pre-allocate these 3 vectors and constantly use them. I think that sounds like a good idea, maybe. So yeah, maybe that's what we're gonna do. Maybe you can add struct for canvas plus canvas stride. So you're trying to group elements. You're trying to sort of force a particular structure on the data before the structure is really visible. You know what I mean? So here's the thing. What if you want to write a function that fills the whole canvas with a particular color, regardless of the dimensions, regardless of the stride? You just want to fill the whole canvas like this. What's interesting is that you only need to do something like this. You never really need a stride. You never really need a stride to actually go ahead and fill the whole canvas with a particular color, right? Because such function doesn't care about the dimension of the canvas. So you not always need a stride, right? You need stride only in the situations when you do care about the dimensions, and if there are situations when you don't care about the dimensions. So you see, it sort of creates more flexible structure for the entities. So some entities may want to group sometimes, but in other situations they don't want to group. So, but if you create a structure up front, you're forcing a particular structure on the data and creating a friction in the places where the friction is not needed yet. I prefer to pass like this soup of data, soup of variables, as long as it doesn't create the problems, and as soon as it creates the problems, the patterns start to emerge, and only then I factor out those patterns into separate structures. So in my opinion, in these particular situations, we don't really have enough information whether we want to group canvas and stride into a separate entity. We just don't have enough code that relies on this kind of stuff. You're rushing the process of designing of API, right? I think the API must emerge from the code. You just have to write something that solves the problem, pass the soup of variables, and then you will see the patterns. We don't have enough information, right? So you see what I mean, MelG1? So you see what I mean? I actually do that intentionally. I know that you can group some variables in some particular fashion. I know that. Like, I can say maybe you can even group like sync in this thing. I don't know. You can group anything actually, but the question is like, why would you do that? Right. I think we don't have enough information to do that yet. And we probably never will have enough information to do that yet, because the code, this code is a throwaway code that I'm probably gonna stop maintaining today. So it's all dependent on the context. So you can rat hole about grouping the data all day long and get nothing done. You can rat hole about it's the same thing as with OP people trying to come up with the perfect hierarchy of abstraction, of like hierarchy of the inheritance. Because you can actually build that hierarchy of inheritance however you want. It just depends on the situation. And rat holing on the hierarchy of the inheritance is just like gets you nowhere at all, right? You get nothing done, right? So, and this is the same situation. You can rat hole about grouping these entities like all day long and get nothing done. So, yeah. Does it make sense? Or I'm not sure if it makes sense, or maybe it requires a clarification or something. So, what are your thoughts? But again, I'm not saying that this is how you have to write things, right? So I'm saying that why I don't like to rat hole about these things, because they make me feel completely unproductive. If that's something that you want to do, if that's something that you value, all power to you, feel free to do that. It's just like I personally don't like to do that because it makes me feel unproductive. Do programmers use recursive functions in real world? Yes, they use them quite often, especially if you need to traverse the hierarchy of files. For instance, if you have a folder and you need to visit each individual file in that folder, you would probably use a recursive algorithm to do that. And this is the most practical usage of recursive algorithm that you can find out there. So, and also in different formats that store things in hierarchical fashion, right? Like trees or something like that, you will probably see recursive algorithms as well. Okay. So yeah, yeah, we have like a bunch of these things. We have like 3 planes and whatnot, and because of that, we probably want to do the following thing. Yeah, I want to now pass not the canvas, but rather YCRCB planes, right? So this is going to be YCRCB444, and this is going to be just the reference to these things. Just a reference to these things. So, and you can just say that we're saving YCRCB444 as frame. And now we don't really have to call this function anymore, right? So what effectively we're doing, right, we are just saying it's a frame, right, and then we're just saving these 3 things. Though this function is so simple that I'm not even sure that we need it, but I mean, maybe it's fine. Maybe it's fine. It just sort of indicates the flow, right? It just indicates the flow. So YCRCB444. Okay, so we generated the first frame, we filled the rectangle and stuff like that, and then I probably want to generate something. So let's actually create like a derive the default thing in here, right? So we're gonna have that. And we're gonna have something like YCRCB444. I'm not really sure if I wanna. So this is such a long name. I don't really like that, and it's. I have an idea for a better name. Let's call it frame. Canvas as frame. So, and that's gonna be the frame. Yeah, let's just call it frame, yeah. And then you can say something like save frame. Okay, that is way more readable, okay. So, and then we're just saving this entire thing, right? We're just saving this entire thing. Okay. So here is the frame. so this is the count, frame counts, and this thing has to be frame index. And the reason why I want to rename this thing is because we will need the word frame, right? So this is going to be let mutable frame, frame default. We're going to create a default empty frame. And so we generated the frame. Then what I'm going to be doing, I'm going to be canvas as frame. So this is going to be the canvas. Canvas as frame. And I suppose canvas, yeah, it doesn't need a modification. So this is going to be the width. And I'm going to provide the mutable reference to the frame. I go canvas as frame. And then I can save the frame, right? So save the frame. I provide the sync, right? And I basically save that frame in there. There we go. So interestingly, that I think canvas frame, first thing it should do, it actually go through all of the planes and clean them, right? So that will enable the reusage of that frame on all of these iterations. So let's actually see if this entire thing compiles. Right, it does not compile because this thing is that. What else do we have in here? So we also need to indicate that this thing is successful. Right, so this thing is successful, and width and height. So yeah, I renamed, oh my god, I renamed all these things, so I'll have to do it like that. Canvas width, canvas height. So canvas width, and this one is going to be canvas width. All right, do we have anything else? Did I call it not canvas width? Am I crazy? I think I'm crazy. Why did I think I called it canvas width? And what is it worth complaining about? It's okay, I see. As U32, that's what this was complaining about. Because I rarely read the error messages, because I don't really find them useful most of the time. So I just look at the code it complains about and try to figure out this thing myself. So right, so frame, this is a frame index, and what else do we have in here? So canvas is not used here because it's not finished. And okay, so we are kind of ready to actually implement that function. So we'll need RGB to YCRCB. All right. RGB to YCRCB. So maybe instead of accepting like these three components, what in reality I'm going to accept, I'm going to accept the pixel, right? So U32. That will make it a little bit easier for me, because then I will get the triple that I can just split into three planes simultaneously and just store them in separate vectors and stuff like that. Right, so I suppose in here I'm going to just do pixel. I'm going to shift it to 8 multiplied by 2. Right, and then or FF, right? So because yeah, that's basically where R is located. So this one is going to be something like this, and 0x FF. I'm not sure if the precedence here is important, right? So I'm going to just put this stuff like that just in case. And the blue is effectively pixel like this. And let's put that like that, 0xff. Okay, so that's a little bit better, hopefully. Okay, so now what we're doing in here is basically, believe it or not, here comes the place where I don't need the canvas stride. I don't need a canvas stride in here, straight up, yeah. So canvas as frame, I just need a sequence of RGB things, and I'm going to be splitting each RGB thing into 3 planes. There we go. I don't need this stride in here, right? And which makes this function more reusable. It makes this function more reusable. Look. It's very important, right? If I introduce something like canvas, and then I had something like, you know, pixels, I would be forced to have this thing as a vector. I would be straight up forced, first of all, to have this thing as a vector, which makes all of these functions not usable on plain arrays, right? Already, if I want to pass a thing, this thing to this function, I would have to pack my pixels to a vector, and I would have zero choice. Literally zero choice to actually use anything else. Slice, subslice, array, out of the window. Instantly. Right, this is first thing. And second thing, I would also have to provide this stride. But what's interesting is that, what if I have a bunch of RGB pixels, bunch of RGB pixels, like right here, where I just put some things in here, and I want to quickly separate them by planes. I can just call this function and don't have to pack it into canvas like quickly. Maybe I can even do it something like that. So canvas as frame, right? And then I can do it like that, and then I can save it as frame. Granted, like frame itself kind of suffers from the same problem. It kind of already suffers from the same problem, but they have a very specific use case for the frame, which probably will fix this kind of thing to a structure. You see, the problem here is that you have to sort of develop an intuition over time on how to separate and group the things. It's not like there's some dogmatic rule that you can just memorize and become a master of API design. There's no such thing. Right, so you constantly need to know like a trade-offs and stuff like that. Right, so in this particular case, this function becomes like reusable by just passing this thing like that and not having a stride. Right, so you see, that person probably left already. I don't know who I'm talking to. Anyways, so yeah. So let's continue. Let me see. So in here we're going to be iterating through the pixels. Right. So which makes it rather convenient, but nobody gives a shit, of course. Okay, so and here we can just put this thing like that. It's going to be YCRCB, right? And then I can easily split these things into the separate planes. So I'm going to just push in it like that. Okay, so yep, that's actually pretty straightforward. I really like how neat and small this function is. So yeah. So this is a reference, so that means we'll have to do it like that. Though we can pass it by the reference. And yeah, by the way, here I don't even have to pass this entire thing, right? So yeah, okay, cool. So everything seems to be working out quite nicely. So then we generate in canvas as a frame, then we save in the frame, and now what we can do, we can call this function yet again for the second time, right? So this is the second time, but we're calling it with a background. So basically we're overriding the rectangle with the background color without need to clean everything, right? So, and after that I'm going to be updating the rectangle +1, right? So it can be plus x, x +1 and y +1. Right, so, and let's recompile the entire stuff. Okay, different kind of patterns. So it seems like it's already fine, right? So let's try to generate the entire thing. Let's see how it goes. So it's generating things, generating frames and stuff like that. So it should generate like a 2 seconds of this stuff. Yep, and let's take a look at the final product. There we go. So that's very interesting. So generated something, but I think player is not really correct on this stuff. So let's actually use the VLC. Yeah. Okay, that's really strange. The background is completely incorrect, which is weird. The background is completely incorrect. So foreground is correct though, but the background is not. And I'm not really sure why. Right, so background, all right. So I suppose one of the things I can try to do is just maybe the ratio is also well, the ratio is, I made it specifically incorrect just in case. Okay. Okay, maybe I should actually just run it with VLC right away, but VLC actually takes too much time to start up. Unfortunately. Why is it using red? Why is it red? So maybe there's something wrong with the fill rect. With the fill rect, because we're iterating through that and stuff. So this is the rectangle, dx dy. Then if it contains the canvas, we use y and x for the canvas stride, and then we set the colors. So that should be fine. I don't see any problems with any of this stuff, if you know what I'm talking about. So what if I set x, I don't know, green? If I fill everything with green, will that work? I don't know. So maybe, yeah, let's actually use background, because it's kind of weird. You know what I'm talking about? It's really weird. Why it is like that? So this is the CBCR, and when I convert it, so oh, it's actually CBCR. Alright, CBCR, and when we're calling to, yeah, it's just like alright, so who knows what the fuck is going on in there. So it's probably about the order of the components of the color or something like that, yeah. Come on. But you can kind of see something going on in here. It's just the colors are fucked. The colors are straight up fucked, and I wonder why. So this is how we converting the entire thing. Writing YCRCD should be fine. Should be fine. Should be fine. So I kind of want to make a small break and make a cup of tea before I go and just try to debug what's going on in here. But maybe I want to remove some of the dead code in here, which is not used, because it's kind of like obscures the entire thing, right? So it's kind of obscures. So let's actually go ahead and, you know, quickly go ahead and remove all of the dead code. Wait, I'm not even recompiling anything. Okay. Classic. Okay, so rust c main.rs. Okay. This one is come on, tell me how that's the sole reason why you have to use cargo. Come on, tell me. Be that person in the chat and just tell me that's why you have to use cargo. Ignoring all of the complexity that cargo introduces to the project, all of the problems and stuff like that, ignoring all of that, just go ahead and tell me that's the sole reason, that's the only and sole reason why you have to use cargo. Ignoring the fact that without the cargo, it's actually super easy to solve that problem by creating a script run sh, right, which constantly rebuilds this entire thing and just runs it all the time, and just using that script instead to run your program. Go ahead and tell me that that's the sole reason why you have to use cargo, ignoring everything else that is going on. Go ahead, come on, be that person. I want to see that person in the chat. Thank you so much. Okay, that's the highly intelligent discussion that I want to see every fucking day. So that is in fact a very highly intelligent discussion. All right, so let's go and boom. Okay, so delta time is not really used right now, so maybe because of that I'm gonna actually remove it. So save frame, unused result, and let's actually unwrap it. So why exactly you don't like cargo? Your question has incorrect premise, and by answering your question you're forcing me to agree with your incorrect premise. Please reword your question. the premise of your question is that I don't like cargo. And you're literally forcing that premise on me, which is extremely rude, by the way. You don't ask questions that force particular promises on people. All right. And I explained the reason why I don't use cargo in this project. You see, I'm not saying that I don't like cargo. I say I don't use cargo in this specific project. You see, I'm actually not agreeing with your premise of your question, right? I'm not agreeing with the premise of your question. The reason I explained that reason at the beginning of the stream, literally there was like, if you go back in the VOD, there was like a couple of sentences that I said why I don't want to use cargo in this specific project. Again, not saying that I don't like cargo. So let's make a small break because I really want to make a cup of tea. All right, let's continue. So I think the problem was that, yeah, I didn't recompile the entire thing. Let's actually see. So let's just run the entire thing. Maybe I'm gonna just be doing it like that. All right. All right. So if I take a look at this thing, it's gonna be VLC. All right. So that makes more sense now. That definitely makes more sense. I suppose I just didn't recompile something. So the problem is that I don't quite understand why the background of like 18, 18, 18, 18 didn't work properly. Maybe again because I didn't recompile at some point. So that could be true, but I'm not 100% sure. That's kind of weird. It sets it to blue. Why does it set it to blue when, so it must be the formula is incorrect or something? It could be the case, actually. It could be the case that the formula of converting... Yeah, so the more I like play with this format, the more I realize that it's just not suitable for what I'm trying to achieve with it. Like, because it just adds this whole level of complexity that is really, really not needed for what I'm trying to achieve. All right. So yeah, it's just so sad, but I want to get it to a working state where it can like generate some images, right? So I don't know. So first of all, I need to double check that the formula that I have in here is correct, right? So let me actually put like to do somewhere. Where is the formula? Yeah, here it is. To do. Is this correct? Right. Is this thing correct? So this one is just RGB. It doesn't really matter. In here, is this correct? Are we placing the components in the right buckets, so to speak? In the right bucket, so to speak, right? So because we have like 3 buckets for different planes, right? So maybe we are not using the correct order for some things in here, so I don't know, it could be anything. And so is this correct, right? Is this correct? Are we saving the planes in the correct order, right? So that's the sources of the problems that I can potentially see. Right, so yeah, let's just go ahead and check all of that. So is this correct? Before maybe I go and you know, check all of that, I'm going to commit everything I have right now. Right, so let's actually go ahead and do that. So it's going to be something like so implement the I will say generate the animated rectangle. The colors are incorrect, but at least it is moving, so it is an animation, which is kind of cool. So we're getting closer to having something interesting, right? We're getting closer to having something actually interesting. All right, so the next thing we need to do. So how can we correct the formula? I just realized that I removed all of the description links. And oh boy, didn't save them for the next video. I'll have to recover them from the previous VOD. Shit. And apparently I need back that documentation that I actually removed. Should have not deleted that, but it is what it is, I suppose. It is what. Here's the formula, by the way. Yeah, so maybe I'm gonna. Yeah, I still have some stuff left. Okay, so I wanted to copy this thing. There we go. So this is the formula, right? So this is the formula, and let's take a look if it's correct or not. So R is the 0, 1, 2. So this is like the second byte. G, so on and so forth. Okay. So Y is effectively 16. 65738 for the R, and then 128057G plus 2564, and all of that is divided by 256. So maybe like I did some modification where I just grouped things in parentheses. So maybe I shouldn't do that. Maybe I'm just gonna do it like this. So it's a little bit closer to the original formula. You know what I'm talking about? Just a little bit closer, so there's less room for a mistake. Right. So and in here, if I remove the parentheses, right, so this is what we get in here. So this is minus that, then divided by that, and then divided by that. There we go. So cool. Everything is sort of aligned. 128 minus 37,944, 256. 744G plus 256. Okay, so everything seems to be all right in here. CR is just that 3R, but without that stuff. So, and in here we can just simply get rid of that, and only that one has to be. So far I don't really see that many mistakes, if you know what I'm talking about. Like, it's just. Yeah, so the only thing in here is that we don't divide R by 256. I have no idea why though. It's kind of strange. So, but R is not divided. Probably have something to do with the perception of, you know, of the colors for the humans. But so far, I didn't see any significant mistakes in here. Right? Maybe I can even do things like that. There we go. So it's essentially basically yeah, taking the vector of the colors and multiplying it by a matrix, right? And that gives you the thing that you want to have. So Y, CB, CR, right? So here's Y, CB, CR. It would be kind of cool to have named tuples, so I would never you know, screw up the orders of the CB and CR and whatnot. So maybe this is something that would be nice to have as a structure. Y, CB, CR, right? And here you would have Y, which is U8, Y, CB, and CR, and then instead of the tuple you would return this structure, right? Because I want it to be named, right? So it's a little bit easier for me to work with. And then I can do YCB. I don't have to do a return, by the way. It doesn't really matter though. YCB CR. There we go. So now the order in which I destructure those things just doesn't matter, right? So I can always refer to this thing by name. Right, so far so good. I didn't see any mistakes in here, right? So let's actually refactor everything. So yeah, this thing has to be. So there's one thing that we probably have to do in here. We have to convert all of that to U8 to the byte, right? So that a little bit later it's easier to work with. Okay, so here I can do something like, can you do YCR? CB, PNG, CBCR. Did I call it CBCR? CBCR. Can I destructurize like this? I wonder. I wonder if I can destructurize like this. Let's actually see. Apparently I can. So that's pretty nice. Isn't that nice? I think that's pretty nice. It's pretty cool. Okay, so I'm sorry, it actually displayed it in a different place. So let me quickly just do VLC. And there we go. As you can see, it's playing animation, but again, the colors are completely incorrect. I have no idea why. So this is precisely what we're trying to investigate in here. Right, so the colors are incorrect, but I think there's no problem in this formula. I went over this formula several times, so I'm gonna just remove this to do. So everything seems to be okay. Right, so let's take a look at this code. So this is the modification that we've done, just in case. So what I'm gonna do, I'm gonna say revise RGB to YCRCB. Right. So this is basically what we did. We revised this entire thing. And if you wanna get the source code of this thing that we're developing in here, you can find this thing in here, right? And for people who's watching on YouTube, you can find this thing in the description, right? So did I put the source code in the description? I think, in fact, I did. Here's the source code in the description. Beautiful. All right, so the next function that we need to revise, just in case, is this thing correct? Right, is this thing correct? So the problem, yeah, so introducing this structure kind of got rid of the problem, right? Because now we refer these things not by order, but by name, right? So it just doesn't matter. Why CBCR? Right, CBCR, it just doesn't matter because, as you can see, we're just referring everything by name and the names match. So I don't think there are any problems in here per se. So that should be fine. That should be fine. So yeah, that's pretty cool. Okay, so let's go ahead and remove that. So I might as well just run this thing one more time. Yep, seems good. And canvas as frame. Revise. And let's just push that right into the repo. Let's just push that right into the repo. Okay, the last thing that we need to revise. Are we saving this thing in a correct order? So the order that everyone's talking about usually about these things is that YCBCR, right? So and we were saving in this kind of order, which is kind of weird. So yeah, so if we take a look at the PNG in here, it's YCBCR. It's YCBCR. So I would presume that you always have to save these planes in that specific order as well. But we can always take a look at the description of the format. So the description of the format can be found in the README. So it's HTTPS, right? So it's HTTPS, and we're gonna put this thing in here. So the description is somewhere here. For those who's watching on Twitch, you can find it in here. And I mean, for people who is watching on YouTube, you can find this link in the README itself, but I can put it in description just in case. Right, so description of UV4 MPEG-2 format, right? So it's actually a very simple format. That's kind of the reason why I'm looking into this format, is that it's extremely simple, right? So yeah. So why CBCR plane order? Okay, so that's basically what they expect in here. So yeah, I don't see any mistakes in here specifically, so everything looks all right. Let's try to generate the thing now. We're doing that in a different order. Why CBCR? Why CBCR? And now it's just red for whatever reason. Okay, so I don't really know. Maybe we're... So the last thing that I see is that maybe we're using incorrect formula. Right, maybe that's the problem. Maybe we're using incorrect formula. In plane order, each frame begins with 5 frames, followed by 0 or more parameters, each preceded by ending with 0. This is then followed by row bytes for from each plane. So we're using specifically 444, so that means the amount of bytes per pixel is 3. So I would presume that I don't know. Do they overlap somehow? Maybe. Maybe I still got the format wrong. That could be the case. Still got the format wrong. What if they do overlap still somehow? What if they do still overlap? Yeah, I feel like maybe I'm packing them incorrectly. Do the sample play correctly in VLC? Oh, that's a good question, actually. So I removed the sample, I think. Samples, because they do play correctly in mPlayer, but mPlayer plays some of ours things incorrectly. So that actually raises a pretty interesting question. What the fuck is going on, am I right? So let's unpack those things, and this one as well. All right, and if I do mPlayer, right, so here's the mPlayer, and here's the ominous cup, right? If I open this stuff in VLC, right, let's take a look at VLC. Yeah, they surprisingly they play correctly, so that means maybe we are doing something horribly wrong. So there was like a couple of weird frames for the cup. Yeah, so it's just place. Yeah, so we're probably maybe packing those things incorrectly. That could be the case, actually. That could be the case. Maybe we can try to pack them slightly differently. Is a packed YCB form in which a pair of consecutive pixels is represented by one sample each but share... Oh, I see. Oh, so... Yeah, okay. This type of data may be packed in a container format. The first pixel for... A byte format. This pixel is a function of... Oh. So it's unclear how many bytes or bits this entire stuff take. So YCBCR444 plain order. So how will it look like? Feel like we're back at the square one yet again. Back at the square one. Which further drives the nail down the fact that this format is just not usable for what I'm trying to use. It's just like not. Yeah. It's just not. CBCR UV444. Like, it's just... Frame rate. Well, I mean, that means... Oh, man. That means you allocate like a 1 byte per each of these components. Is that... It's just like so little information about that. It's just makes me so sad. Okay, so what if we just try different orders of these things? I don't know. What if I put luminous somewhere here? I don't fucking know at this point anymore. Like, yeah, according to my understanding, it just have to take 3 bytes, so you have a 1 byte per component, right? That's what you have. You have a 1 byte per component, and that makes sense. Do I have to pack them somehow further? There's so little information about how I'm supposed to pack them. It's insane. There's all this weird shit that has nothing to do with how you pack them, and it's just like, yeah, it's just like not helpful at all. I don't know. So, and again, the case could be that they may not be, the problem may not be in order. Maybe the bytes, maybe like Lumina takes 4 beats and you're supposed to do something else. No, 444 has nothing to do with bytes or something. I think it has something to do with frame rate or something like, so you have 4 luminous per 4 red shift and blue shift or something like that. It's just like insanely obscure, like intentionally. And it just like drives me nuts. There's no like a simple, you know, explanation. Okay, so this is how you lay it out in the memory, so this is how we can read that. No, it have to be like this. Anyway, so 444 YCBCR. So we can try to read the other ones, and okay, indicates that a planar color space where 2 by 2 block of pixels in an image is represented by 4, 1 for each pixel, but all 4 pixels share the same. Okay, so can be transported within the general purpose container format. For trivia, it's not fucking helpful. Like, it's just like, show me the picture. How do you want it to be placed in memory? It's just, it drives me nuts. And the one that I want to use doesn't even have explanation. It's just like, I want to make a small break. Look, this makes me so upset, right? Because I know it is simple. There's the difficulty of this problem is completely artificial. That's why I'm so upset. It's just like, yeah, you just want this thing in a particular bit, byte, whatever the fuck order, but you won't tell me in a normal human language because fuck me, apparently, right? So and that's what makes me upset. It's just like, it looks like a gatekeeping problem, right? If you just showed me, like, how do you want this layout in the memory? Like, what do you want? I would be able to do that, but you won't tell me because whatever reason, I don't know. So yeah, let's make a small break. This shit just makes me upset, like, down to the core. Alright, so I have a weird suspicion, which I wanna kinda test, but I'm not sure how to test that properly. So basically, I have a feeling that some of these components may not fit into a single byte, and some of them may be smaller than byte. And because of that, the sum of the sizes of this thing may be 3 bytes, but not necessarily this thing take 3 bytes. You know what I'm talking about? But they do divide by 256, which makes me believe that maybe that's what you want, but it's really weird. So I want to basically iterate through all of the possible, like, through the whole RGB space and compute the maximum and minimum for Y, CB, and CR. In floats though, so it has to be in floats. Right, so I need a different function and different structure which actually works with floats instead. I just want to see what's gonna happen in this particular case. And maybe some of them could be negative, by the way, so I have to be aware of that too. So because there's like subtraction in here or something like that, it's kind of difficult to derive what's happening in this formula. Right, so I'm gonna go and just like conduct an experiment, right? So we're gonna conduct an experiment and see what's gonna happen in here. So this is gonna be F, this is gonna be F. So, and because of that, I'm gonna be copy-pasting this entire thing in here. So this is gonna be F, but this time we're not converting it to U8, right? So we're gonna be using the floats. We're gonna be using the floats, there we go. So where is the main? It's gonna be 2. And here I'm going to be iterating through the entire RGB space, right? So it's going to be for R in 256, right? So, and we can repeat that for G, and we can repeat that for B. There we go. So R, G, and B, and I need to construct this entire. To be fair, I don't need to do that, because what I can do is I can just do pixel in 0, then x 1 0 0 0 0 0 0. So that will iterate through everything 0 to x f f f f f f, right? So it will iterate each individual pixel. Okay, that's cool. So I need to do this kind of shit. which makes it relatively convenient to iterate the whole RGB space. Okay. So can I actually make a YCR-CF comparable? Something like derive, right? Derive partial ORD, right? So this is what I want to be able to do. So I want this thing to be comparable, and after that. Oh, that's pretty cool. So can I effectively take this entire range, right, and map it with RGB to YCR-CBF, and then find the maximum between these entire things, right? And yeah, just print this entire maximum like that. So I should be able to just do that, right? So the well, maybe there's some details which will prevent me from doing that, but that would be actually kind of cool if I could just do that, if the YCR-CB is comparable. Well, no. So it compares this thing as separate components, right? It compares these things as separate components, so which will not allow me to compare things properly. So I'll probably have to write some sort of a fold, if you know what I'm talking about. So it's more of a fold, right? Fold left even, right? Where I would have an accumulator, right? Some sort of accumulator. So here's a map. Here's the fold. The accumulator and the current X, and within that accumulator I will have to basically do YCBCRF, right, where essentially Y is going to be equal to the maximum CMP max between accumulator Y and XY. Then Y is going to be replaced with CB, and this one is going to be replaced with CR. Right, CR, there we go. So that's how we're gonna be doing all of that. And as far as I know, fold will also accept the default value, so the minimum, the absolute minimum, which I'm not really sure how to do that. Maybe there is a version of fold that actually uses first element as the minimum or something like that. So that's roughly the idea that I want to have. Let's see if I can compile that. So what the compiler will tell me. So CMP, so we probably need to import std CMP first, right? So let's actually see. Partial ORD, so cannot compare CR7, no implementation for equality, so I need a partial equality in here as well. Okay, so that's fine, that's what you want. Okay, so method not found, there is no fold left. Okay, so that's fine, we can try to find that. stdlib. So fold. So we can just have fold, but which fold is that? It's a fold left or a fold right? Folds every element into accumulator by applying the operation, blah blah blah, takes two arguments, I don't care, is that a left fold or right fold? Reduce can be used to use the first element. Okay, so there is a reduce, which is probably what I want in this particular case. Okay, so this is a reduce, cool. So what else do we have in here? CMP, the trait F3 is not satisfied. The trait ORD is not satisfied for F32. You cannot compare through ORD F32 because programmers should be scared of comparing floating point numbers because it's so fragile and programmers have no time and ability to learn IEEE 754. So that's probably the reason. But maybe there's other reasons. Let's actually see. F32. So comparing floating points, floating point numbers is as scary as working with pointers. I do understand that. It is very, very scary. So does it? Where is the primitive type? I wanna see the Oh my god, the website is so slow. Holy fucking shit. Primitive type. Okay. So so what does it implement? What does it implement? So partial ORD, so it does have a partial ORD, partial CMP, which returns you ordering. So, and for some reason max does not give you the CMP thingy. Comparison just maximum of two values, returns them. So, y, CBCR, y, it's gonna be f, CBCR, f. So maybe I'll have to do some other stuff. So, yeah, so I think this thing has to be clonable and copyable, just in case. Right. Clonable and copyable. If x, let's actually call it a and b. Y is, what is it called? Less than by, right? So what I want to do in this particular case is set by, right? So I want to have a maximum between these two things. This can be CB, CR. So I'm going to just return A. So probably I have to make it mutable, because why not, right? So why wouldn't you like make your life miserable on a throwaway code? Of course. Okay, so what do you want? So you can not make it this thing mutable, but I do want to make it mutable. Okay, so perfect. I have something like this, and the only thing I want in my entire life is freaking just do that. Just like give me the way to do that. Holy shit. Okay. Can I just have that already? So this is unused, and alright, so option does not implement display. Okay, whatever, I don't care. So what do you have in here? Cannot be formatted. Okay, so that means I need to do something like debug. Right, so is not declared as mutable, right? So where do I put mutable? So I have to put mutable a in here. So it's not a type, it's for a variable. Like in any other language, I would be already done by this time. Holy fucking shit. Okay, so one more time. Can you show me the results? Okay, finally. All right, so now we're freaking talking. Now we are freaking talking. So here is the thing. Why the fuck CR is so big? That's what I'm talking about. Why the fuck CR is so big? This is not right. Right. And CR is the one which we didn't divide by. Is the formula incorrect? Is this a bug in this formula? I think we just found a bug in this formula. Holy freaking shit. Okay, so if I try to do that, if I put this thing in here, now it makes sense. Now all of them fit into the byte, and that makes sense. That effect makes sense. And if I just do something like this, right? So right, so we'll try to find the minimum, and the minimum should be like around 0, right? So it's actually closer to 16. Okay, and I remember in the previous stream somebody even told me, like, yeah, bro, you don't have to divide it, you have a bug in here. So apparently there's a bug in documentation. The formula is freaking incorrect. The formula is freaking incorrect. Okay, so you know how I found this RGB to YCBCR? So there was a PDF. I don't remember where we found that PDF. So convert. So was it something like RGB to YCBCR4? I can't find this PDF anymore, but this PDF is incorrect. It is freaking incorrect. And now it's gone, right? Now it's freaking gone. So yeah. Does anyone remember? So something like a microcode, so something. I don't remember. maybe YCBCR442 RGB. Am I imagining that? I cannot find that shit anymore. Now it's gone. Like, it's not appearing anywhere. This is so bad. That caused me like a 2 days of fucking misery. Holy freaking shit. Oh, I swear to God, people. Holy fuck. Okay, we found a bug apparently. We found a bug. Okay, so at least we know. Should have actually done that. Like, I kind of low-key wanted to do that. Right, but then I decided not to for whatever reason. So, and actually that makes it relative. Well, I mean, I'm gonna keep it as divided by 256, doesn't really matter. So now I can remove all of this trash. I don't really care. So all of that is throwaway code. Imagine in a language where you want to quickly write a throwaway code and it just keep annoying you with this useless shit that you don't care about. Right, you just want to test something. Right, just want to check something, but no, you have to do that, ORD, implement ORD, no, you have to implement it. Holy shit. Anyway, so, in this language it's impossible to write throwaway code in a comfortable way, without rage quitting, of course. Okay, so we're doing something at least. Okay, so it's kind of close to what I want to have in here. So, but, okay. Alright, that makes sense. So, we fill everything with the background, right? So this is the background, this is a foreground. And, yeah, that's strange. That is strange, that is strange. So the background is supposed to be like grayish. Oh, I also was messing with the orders. Yeah. So I was also was messing with the orders. So it's a YCBCR. Yeah. So here this YCBCR. Nice intuition, by the way. Which intuition? I don't understand what you're talking about. Provide more context when you say something like that, please. Otherwise, I won't be able to understand you. So, yeah, music is kind of sus. I don't like this music. Fuck that music. So background, foreground. So it's saying the frame. And now, how am I supposed to trust this? How do we know that there's something else in this formula that is incorrect? How do we fucking know? Okay, let's actually use Wikipedia. Fuck that source. I'm gonna go to Wikipedia because, like, I don't know. Like, how am I supposed to trust this thing now? Wikipedia, like YCBCR. All right. So where is the conversion thing? So this is for like different stuff, I suppose. Okay, so this is the one that we probably want because the numbers look similar. So alternative digital can derive and they divide by 250. Well, I mean, depends. The formula is scaling factor multiplied by 250. This allows for value in the denominator which can be calculated by the bit shift. I see. So it's for the bit shift or something like that, but don't really care. So okay, let's actually try to apply this formula then. So, oh my god, like, and now I lost the place where was the formula, of course. Okay, 65, 256. Okay, that's the place. 16, 65, 738 RF. 125, 264. So this is CB minus. We need to check the signs correctly, right? So the signs are important. 74. That's the one. It's the one. So this is a minus minus. then plus, then minus. Okay, I didn't see any mistakes in here, so it seems all right to me. Seems kind of all right to me. All right, so yeah. So then we convert in everything. So this is RGB, doesn't matter. So canvas as frame, we clean all of the planes, then we push everything to the corresponding place, and when we saving everything, it says YCBCR. So I don't see any problems in here. So, but maybe there are still problems. Okay, let's give it a try. Let's give it a try. I think this was correct. I think, oh, maybe, wait, maybe this is the problem with my monitor. God damn it. I think, yeah, I looked at the monitor in a really weird angle and the colors were screwed up. Yeah, this is correct. This is straight up correct. Let's actually try with mPlayer. Right, so this is going to be mPlayer. Yes, that should be fine. I think mPlayer yet again confusing red and blue or something like that. On top of that, I think I want to make this thing like this. Right, so I want it like that. So I want the red to be a little bit brighter. You know what I'm talking about? Okay, so it's mPlayer that is incorrect. It's mPlayer. mPlayer actually screwed up completely. VLC is correct because I meant red in this particular case. Yeah, I meant red. There we go. So that's precisely what I wanted to render. God damn it. That's precisely what I wanted. Finally, it took me so much time, so much misery. Holy fucking shit. Okay. So, yep, we did it, I suppose. Yep. Fix the colors. Fix the colors. Okay, now, maybe now we can try to do the thing where we, you know, sync the animation with the time, right? So essentially make the thing move faster and also bounce off of the edges and stuff like that. And there we go. So actually, Binyar, you're right. What if we make it... What if we animate this entire thing to have like HSL animation? That sounds like a pretty cool idea. Though, yeah, we can try. We can try. Sounds like a pretty interesting thing to do. But it will probably take too much time, right? So, so we need a similar signature in here, right? Pretty much similar signature. But we don't have to provide the color, but we may provide the offset for the HSLA, right? We may provide the offset for HSLA. So, okay, so this one is going to be the color, right? Because at least it's going to be interesting, I suppose. Right? At least it's going to be interesting. So this stuff is going to be pretty much the same, as far as you can tell. This stuff is pretty much the same, and we're iterating that stuff in pretty much the same fashion, right? Except after we've got X and Y, right? I think we need to interpolate X and Y. So this is going to be U, and I'm going to take X and divide it by W. Both of these things has to be, you know, F32. This is going to be V, Y, and H. There we go. So, so we have UV coordinates, and I want to use UV coordinates for HSLA. So I already used HSLA conversion in one of my projects, EmoteJam. You can find the source code of this project in here if you're interested, and I'm gonna put this thing in the description as well, right? So EmoteJam. So it's a very simple website that just makes animated emotes, right? So essentially you upload a static emote in here, right? And it can make it animated, right? So you can bounce around, and then you can just render it into a GIF. which you then can download and upload to BTTV. This was actually done before Twitch released its animated emote thingy. So, but we have a lot of different filters in here. So one of the filters we have is a pride filter, which basically animates HSLA colors. HSL is a representation of the color and stuff like that. So, and I want to try to do a similar thing right now, but for the video. So it's done on a shader, so I think I'm gonna yoink the shader from somewhere. So where is the filters in here? I think the filters are somewhere here. So here's the filters, and we're gonna find the pride filter, and here is the formula, hopefully. Well, here's the formula that basically converts HSLA to RGB. So we need to port that to Rust now, somehow. So let's go ahead and do that. Let's go ahead and do that. So here we, yeah. So I probably need to rename this function to something else, but first I'm gonna be actually converting this stuff in here. Oh boy, that's a lot of shit to actually port. God fucking damn it. Ah, don't want to do that. Alright, so HSLA will give me RGB, right? So it will give me RGB, and then I'll be able to set that RGB to something. Okay, so feel, I don't know, gay rect. It's called gay rect. So now let's try to have a function that is called HSL to RGB, right? So here we're gonna have H, and I think we're gonna accept those things in floats. I think that's the easiest thing to do in here, because roughly, yeah, so all of that is basically in floats. So this hue is gonna be H32, and the S is going to be F32, and L is going to be F32, and this entire thing will give us RGB, but it will give us RGB in normalized order, so it's going to be F32, 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 so because I'm basically, you know, converting this entire thing. So, okay, so let's try to convert first this stuff, right? How can we convert this stuff? This stuff is going to be very interesting, right? CX, right? So CX is effectively H, right? And then we have these three components, right? So these are the three components. So what I'm thinking is that maybe we can have something like R, which is initially going to be 0, 0, 0. So we're porting this kind of part. R is 0, G is 4, and B is 2. There we go. So we have that, and after that we need to add to each an individual component in here H multiplied by 6, right? So that's basically what we're doing in here, right? So that's basically what this entire thing means. And then we need to do something like fmod. The question is, do we have fmod? stdlib, rus stdlib, something like this. Mod. Does f32 have a method for mod or something? There we go. Do you have mod? Or don't you have mod? No, it doesn't have mod. But Zozin in nightly. Oh, nightly. So, okay. Really? Maybe you can use a mod operator for f32. Because it's really hard for me to take this language seriously, so come on. Okay, so if I do something like So it's probably not gonna work, right? So color not found in the scope. I really don't care. Could you please just compile? Thank you. Okay, so mod at least didn't crash or anything. Right, but it's not a correct mod either, right, in a mathematical sense. Right. So, okay, so you can use mod, but what if I have a fractional parts in here? Will you work with fraction? Okay, so it works with fractional, which is already cool. Okay, I can appreciate that. So, so there's probably a trait for the mod. I remember there was a RAM trait, right? So there was a RAM trait, and F32 basically implements that thing. Okay. So there's also like a Euclidean or something, Euclidean, but I remember seeing it, RAM Euclidean, come on. So yeah, you can use a RAM Euclidean because of course it has to be, you know, smart ass like that. Okay, so that means I can do something like this, right? And then minus like this. What do we have? It's not available because I have to import something, no? What do you want from me? Euclid, is it called something differently? We have to 138. Wait, 138. Do I have an old compiler? So if I take a look at the Rust, well, I mean, no, it's definitely not old. I'm not up to date with the latest compilers bullshit. I'm sorry. So maybe a RAM is, I don't know. My brain is actually shutting down, so I probably need to make a small break. I'm just like super tired. Should be just available on F32. Did I make a typo? No, I didn't make a typo. I didn't make a typo. Is that because it's not a float or something? It's freaking Haskell all over the place, all over again. I mean, it's like literally Haskell all over again because it even has the same problem as Haskell, right? Okay, so we have that. So I forgot what I needed it for. I was porting HSL, right? So I was porting HSL. Cool. HSL to RGB. Okay, let's go back here. So that's what I was doing. Holy fuck. Okay, so here's the mod, and what I need to do in here, right, is RAM Euclid. Right, so this is the mod RAM Euclid 6. Okay, so we managed to port this part, this whole part. Right, so here's this whole part is ported. So now we need to subtract 3. So here is the 3. It's been successfully subtracted. ABS. So ABS, is it available as the method of? Yeah, it is available. Okay. So alright. So this is going to be something like this, and then we can just do something like ABS. Alright. So here's the ABS, and then we have to subtract 1. we're subtracting 1. And then we need to clamp all of these things between 0 and 1. Do we have clamp? We do have clamp. Okay, that's cool. Clamp between 0 and 1. Cool. So we ported this entire line. Nice. So now what we have to return? We have to return these things. So we need to do additional transformations on these things to be able to do all of that. So here we return vector 3. So CZ, so if I understand correctly, it's H and Z is L, right? So this is luminosity and CY is saturation. Okay, that's pretty cool. So after all of that, right, we have to subtract half from all of these things, right? So it has to be half, but for all of them. Right, so it's going to be G, and this is going to be a B. So we're subtracting half. That's cool. Then we're multiplying all of that by saturation, right? Of our nation. And then we need to multiply it by this value, right? So L and this value are scalars, so I don't have to really worry about that too much. So we'll see. So that means here, might as well actually, yeah, I want to try this. Right. Emacs, freaking Emacs. Okay, multiply that. Then we're going to be doing that. And we need to multiply this stuff by this value. So I don't know how I'm going to call this value. It's going to be something like T, whatever, don't care. So here's that. And what I need to do in here, I just need to call ABS like this and then multiply this. Why did you fucking jump in there? Okay, all right. Cool, finally. Holy shit. Can I just return it now? RGB. There we go. Okay. Did I port it? Hopefully I ported it. So HSL to RGB. And all of that is normalized. It's quite important to remember. So we're doing floating point shifting. Well, yeah, that's such a necessary thing. You have to put it at the top in here, of course. Such an important fucking thing. So what do you want from me? Main function not found. Okay, so we're gonna put it like this. What else do you want from me? Show me errors. I don't give a shit about these stupid warnings. Okay, so this thing has to be mutable. Okay, so finally, so do we have any other errors? Okay, so it's rendering shit, so we don't need that. Okay, so we have UV. Right, so, and let's do it like this. UV is going to affect the hue, right? So that's basically what we're using in here. So this is the hue. The saturation is going to be like 80%, and the value, I think we can steal that from here. Yeah, saturation has to be probably full, and the value is around like this. And that gives us RGB, but in floating point, right? So it's going to be RF, GF, and BF, right? RF, GF, and BF. There we go. And we'll need to convert that to the like pixels and whatnot, right? So we'll need to have something like RF multiplied by, I might spell there something like this, RF multiplied by 255, right, and converted to as U, and shifted by this amount of things, right, and we need to do that for G, which is located somewhere here, and B, which is located at the 0 spot, right, and we want to combine all of these things with OR, right, and then we're going to place this thing into the canvas, right, so we're placing this entire thing into the canvas. Can you just give me this kind of stuff? Will that compile? Let's see. Of course it won't, because fuck me. Okay, so maybe this has to be actually 32. Sure, why not? Interpreted, it wants more parentheses. So I always thought that Rust wants to be Haskell. In reality, it wants to be Lisp. Okay, so we're rendering shit. Okay, so let's open the video, right? So here's the video, and what do we have here? And it didn't work because we never called this function, right? Because we never called it. So we have a feel rect, and now let's feel gay rect. There we go. So oh fuck, it's a wrong thing. Okay, let's regenerate this entire thing. It doesn't work because you don't need to have... Oh yeah, okay, so I see. It has to be something like this, and then we fill it with the background. Okay, but you don't need a foreground though, right, to do that. You don't need a foreground. So yeah, let's see how it's gonna be doing that. Alright, and well, that's very interesting. So it's kinda rainbowish, but not really. So I think we need to now shift, like offset the entire thing somehow. Well, right now to make it like more tight, we can actually multiply the you know, u plus v with some sort of a scalar, if you know what I'm talking about, right? Some sort of a scalar. And why do you redirect me to a wrong buffer, Emacs? Emacs, what the fuck is wrong with you, Emacs? Okay, let me actually also input VLC with this. Okay. Look at that. It was kinda animating already. It was in fact kind of animating. So if we actually make it like 10 times faster, right? So look at that. Look at that. I'm gonna be making it 10 times faster. It's already animating. I wonder why is it animating? I think I know why. Because I'm using the X and Y on the surface itself. Oh yeah, so because it's changing the position and that's why it is animating. Right, that's actually pretty cool. Look at that shit. Does anyone give a shit? I think nobody gives a shit. Okay. Alright, so yeah. So we have a rainbowish triangle. I suppose I'm gonna go make a break because yeah, nobody gives a shit. Alright. Alright, we're back. So let me see. So we managed to generate this video, right? And we have this rainbowish triangle. Maybe we could make this rainbowish triangle a little bit bigger, but maybe it will affect the generation times. Let's actually multiply this thing by 2, right, to make it a little bit bigger. Right. So we don't even need foreground color anymore, but maybe we'll need it in the future at some point. It does slow down things quite a bit. This is look nice. So let's take a look at the size of the file, right? So it's 83 megabytes. What if I try to convert this file to now something more reasonable, right? So let's actually convert it to output MP4. Alright, so that didn't really... Oh, it doesn't need O in here. Okay, so, and yeah, it compressed 83 megabytes to 15 kilobytes, right? So, and now if I take a look at this entire thing in VLC, yep. Does look reasonable. We can try to increase FPS, alright, so right now we have 30 FPS. What about 60 FPS? What about 60 FPS? It will take some like a longer time, twice as long to generate, but maybe it's going to be smoother. Also, it's going to be faster because right now we have a FPS locked physics. How is that called? FPS dependent physics, right? So the physics depend on the FPS. right? So yeah, it moves way faster, but it's actually smoother. It's actually smoother. Right, so and if I try to convert this entire thing, yeah, override, of course. It does not know, so let's actually put some sort of a Y flag. Oh, where's my compilation thingy? All right, so yeah, it says 16 kilobytes, and yep. And what I'm gonna do right now, I'm going to go to my Discord server, and I'm gonna upload this video in here for everyone. I don't know why, but I kind of want to upload that. So metaballs, 2mpeg4yuv, and so I'm gonna just upload this thing. I wonder how it's gonna look like. Looks alright. So yeah. Even so, now we can generate videos that can be displayed in Discord, but then granted we'll have to use ffmpeg to convert everything, but yeah, so that's pretty cool. But that's not really what I want you to do in here, right? I want you to actually animate this entire thing. I want you to make it like a bounce off of the edges and stuff like that. But to do all of that, I need like FPS Independent Physics, right? So that's what I need, FPS Independent Physics. So let's actually do something like delta time, right? It's going to be f32, and I'm going to take this thing and divide by FPS as f32. There we go. So that's what we have in here, and now we should be able to do a little bit of a physics, right? So rect, let's say that rect is going to be f32 as well, because we're going to be doing all the physics in floating point. We need to maybe decide what's going to be the velocity of the rectangle, right? So let's go and say that the rect velocity, right? So rect velocity is going to be 100 pixels per second, right? So, and as you can see, this value can be fractional, right? So this value can be fractional. Also, we need to have something like rect direction, dx, right? So it's going to be 1 now and dy. Right, and this is something that we can use to modify the direction in which the entire thing is moving, right? So that's what we can do in here. So here we have rect x, and I'm going to add rect dx and dy multiplied by rect velocity. Actually, I need to multiply it like this, rect velocity, and also multiplied by delta time, right? So because it's related to delta time, and delta time is log to FPS. So that's basically what we're doing here. Right, so, and let's see how it's gonna look like. This is not what I wanted to do, excuse me. I wanted to just do that. And it doesn't compile. Okay, so this is because we have to, yeah, we have to convert floats to I32, right, as I32, as I32. As I32. Okay, so is it gonna work? Is it gonna work now, yo? Yeah, maybe I need to reduce FPS because at 60 FPS it just takes too much time, man. All right, so yeah, that looks pretty poug, isn't it? Let's reduce FPS. Let's go to FPS. So, and regardless of FPS, it should actually move with the same velocity, right? Because the physics is FPS independent now. The physics is FPS independent. Boom, and yeah. Let's actually take a look at how it looks like in mPlayer, I wonder. Right, so mPlayer, we know that it has a bug where it incorrectly displays the things. So, yeah, I just want to see. But I like how quickly mPlayer... No, it's actually fine. Which is rather strange, right? Output y for m. Yeah, maybe I'm gonna use mPlayer because it's just like a little bit nicer. It starts up a little bit faster, so I'm gonna use that. Anyway, so we can modify the velocity, rect velocity, and let's actually make it twice as faster so it has enough time to actually reach the edge of the screen, right? So maybe it also would make sense to enable like crank up optimization level of the compiler. So maybe that will make the compilation a bit faster. COPT level is that what it is? COPT level 3. Can I do the shit like that? Okay, that's actually nice. Okay, so I actually speed up the entire thing. Yeah, let's actually do all of that with a, you know, with a higher optimization level. Right, so maybe now 60 FPS is more feasible, right? So 60 FPS should be more feasible now. Yeah, nice. So we're gonna do that at 60 FPS. So in 60 FPS, okay. So, and maybe because of that, we can actually increase the duration. Let's say that we're gonna have 3 seconds. So what's gonna be the most like reasonable thing to have? 3 seconds, probably too much already. But I want to give it enough time to actually bounce off of these things. Yeah, okay. So now let's check for bouncing off of the edges, right? If rect is greater or equal, right? If it's greater or equal to the width, right? To the width, I'm going to be taking rect dx and multiply it by -1, right? So the same will happen for y, essentially, right? The same will happen for y. So let's see how it's gonna go. Well, it didn't like that because it was an integer, of course. It was an integer. Okay. And it didn't work. Nice. So because I'm supposed to be using height, right? And I think we have to actually add rect width and rect height, right, to the mix, and all of these things have to be used like F32 as well as F32. Okay. So maybe I think I need to increase the speed of this thing. Yeah, it should be faster, and it actually bounces up. All right, so let's go to the velocity, and let's make the velocity like 500. So it will just go a bit faster, hopefully. It also takes a bit of time for mPlayer to parse everything. Okay, so that's cool. So it bounced off of the 2 edges already, which is cool. Right, and now we need to fix the situation when rect becomes negative, right? So when it's that, or rect x less or equal than 0, right? Or rect y less or equal than 0. Okay, it has to be this thing. Okay. Almost hit the corner. Almost hit the corner. Okay, so we're getting somewhere. So what if I speed it up even more? So how is it gonna go? The triangle goes brrr. The triangle goes brrr. All right. So mPlayer, I'll put y for m and yesu kawaii freaking desu. So, and the duration in this case is basically 3 seconds. So in 3 seconds it's capable of just doing this kind of stuff, which is cool. All right, so foreground, we don't use foreground, but I'm not sure if we'll need it at some point. I think we will need it at some point, so I'm just gonna keep it like this. Okay, so what if I now try to convert the entire thing via FFmpeg? All right, so yes, so it takes some time. So 40 kilobytes, and then if I play this with mPlayer, yeah, there we go. Cool. Now let's see how it looks like in Discord. All right, we're gonna be testing it with the Discord. Should be fine, I suppose. And the cool thing is that this video is generated from scratch in a Rust program that doesn't use any cargo and any third-party dependencies. Think about it. You may think about ffmpeg as a third-party dependency, but it's not a third-party dependency of a Rust program, right? You can still keep your Rust program dependency-less, right, without using cargo or anything like that. And basically, this approach makes it feasible for any language. I could rewrite this entire thing in any language, and it will be pretty much the same. So yeah, that's basically what it is effectively. Become smaller than GIF. I mean, that's a video format. So that's pretty cool. That is in fact pretty cool, and 60 FPS. That is really neat. Okay, so let's take a look at to-do, right? So we have a to-do list, animate something like a square bounces off the walls of the screen. We kind of did that, but I want to make something more interesting. What if we render the rectangle as a regular rectangle with a foreground and whatnot, right? With the foreground. So let me try to do that. And make it rainbowish only when it hits the walls. So what is it? What it doesn't like? I'm not sure. What do you want from me? 3 arguments. What? Color. I provided the color. Foreground. There we go. Here's the color. Oh my god! I just like forgot to save something or whatever. Okay. Whatever. All right. So here's that. So we have this kind of thing, you know, flying around and whatnot. Maybe we can even make it so it's like 28, 28, 28. Right, it's gonna be sort of like a boring rectangle flying around. Right, so that's gonna be the idea. A boring rectangle flying around. Maybe it could be even brighter than this. Right, so let's say that it's gonna be even brighter. Right, so let's say 38, maybe 48. Okay. So, and every time it hits the wall, right, every time it detects that it hit the wall, it will become rainbowish for some, like some amount of seconds, right, or something like that, and then go back to greenish or whatnot, to grayish. Grayish. So, and let's put maybe 6. I want it to be a little bit more bright now. So the question is, how are we going to be implementing that? So how are we going to be implementing that? We can introduce some sort of a value, right? Some sort of a value, A, which holds the seconds, right? Which holds the seconds. And here is an interesting thing. If A is greater than 0, we are rendering this thing in a rainbowish manner without a foreground, like this. Otherwise, we're rendering it as a gray one, right? And each frame, we are subtracting the delta time from A. And every time you hit something, we set A to a particular value. So for the duration of the rainbow, right? A rainbow duration. So this is going to be rainbow duration, a rainbow duration, right? So, and this could be a constant, right? That we can put somewhere here. So let's call it video duration, and this one is going to be rainbow duration at 32. So since the video duration is 3 seconds, the rainbow duration has to be maybe like you know, milliseconds. Maybe it's going to be like 100 milliseconds or so, right? So compilation, video duration. All right, so let's see if it's going to work. Boom, 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 boom. That's not bad. So that means it could be a little bit, you know, longer, like twice as long, for instance. Twice as long, for instance. Boom, 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 boom. From grayish to grayish. Okay. Nice one. So, yeah, there we go. It's interesting is that it generated everything, right? But then it waits. Is that because mPlayer tries to parse it or something? Could be that. I've just got a pretty cool idea. What if... to be fair, it doesn't really look that spectacular. I don't like that. It looks way better if it's always rainbowish, so I think I'm gonna leave it as it is, so it's always gonna be rainbowish. I was hoping that it's gonna look interesting, but nah. Let's just make it always like that. So I have the idea. What if every time it hits the wall, it actually splits in two smaller rectangles? If you know what I'm talking about. Right, so, and they basically move in different directions. Right, how about that? Is that a cool idea? Yeah. We can try to split them. So, but for that we'll need to introduce like a rectangle entity, right? Rectangle entity that will hold the position of the rectangle, the current direction of the rectangle, the current size of the rectangle, and so on and so forth. Right, so let's actually go ahead and introduce that. So it's going to be structure rect, right? It has a position x, which is f32, and then y, which is f32. The width and height, I wonder what's going to be the width and height. Is it going to be like in integer pixels or not in integer pixels? That's a good question. So I think it's going to be in integer pixels for now, at least. Later we can do something about that. So we also need to have a direction. The velocity of those things is going to be you know, the constant, but maybe we can change the velocity of those things at some point. Who knows? Yeah. So that's the things that we want to have, right? That's the things we want to have. So what's funny is that so I have an idea. Right, let's replace this thing with that single rect. Right, we're gonna have a mutable rect, which is effectively this. So the initial position is going to be 0 and 0, right? And the initial velocity, we can put it like this, it's going to be dx. 1, 1. Do we need anything else? Probably. I think width has to be a rect width, and height is going to be a rect height. There we go. So that's the thing we need, and I'm going to be just removing this entire stuff, right? So, and after that, once we integrate this entire thing into the rendering process, we'll be able to have an array of such rectangles. You know what I'm talking about? Like an array of them. Now, so I think I have to use like a colon. Oh shit. Yeah, colon. So, okay, so in here, if I want to render something, I have to have this sort of like a boundary box thingy, which I probably want to extract from the rect itself. So I have an idea. If I implement rect, I want to implement a method called hitbox, and the hitbox effectively will return me i32, i32, u32, u32, which is compatible with fill rect RGBA, right? So you'll be able to put this thing in here. So this is the hitbox. And the way we're going to generate the hitbox, of course, this entire thing should tell self x as i32, self y as i32, self w, self h. There we go. So that's basically what we want to have in here. And in here, I'm going to just grab this entire thing and say rect, did I do it correctly? Yeah, rect hitbox. There we go. So we compressed the code a little bit. Rect hitbox. And now it became a little bit more readable. right? So we're starting to compress things around. Okay, so what else do we have in here? So rect x. Okay, so what we're effectively doing in here, we're updating a single rectangle, but since we're going to have several rectangles, their update function is going to be different and independent. So I think we just need to introduce a method called update, which takes a mutable self and doesn't really do anything. Right, so, and I would be, doesn't return anything, that's what I wanted to say. I'm going to replace this entire thing with the rect update. There we go, so we have a rect update, then I'm going to put this thing in here. Right, and here, what I want to do probably, I want to query replace rect underscore with self dot, and that's roughly what I need to do in here. So I guess that is it, except self width and height is kind of sus. Okay, so this one has to be self width, and width is the canvas, right? So this one is going to be self height, right? There we go. So self velocity. Well, this one is not really self velocity. It's like the velocity is going to be the same for everyone, so I'm going to do rect velocity. All right, so that should be it. Can we now compile it? I think rect width as U32 as U32. There we go. And I think, yeah, I think we did it. So we introduced rect entity. We've sort of like factored out that rect entity. And now we should be able to even have an array of such rects, right? So I can now introduce mute rects, which is going to be a vector, vector of rects, like so. I'm not sure, I think this is how I have to do that, so this is going to be new. There we go. So, and this entire thing is going to be simply taking rects and pushing a new rect into that. There we go. And then, when I'm rendering the rectangles, I just need to do it like this. So for each rect in rects, I just need to do a rect hitbox. Then I need to take the canvas and turn it into a frame. Then I need to save the frame, and then I'm going to do rect in rects, and I'm going to just clean everything up. And after we cleaned everything up, we're going to be updating the rects in rects like so. There we go. Alrighty, so this one has to be something like this. There we go. So rects move occurs or something, so I probably have to do iter instead, right? So it has to be iter, there we go. So what do we have in here? So at iter mute, this one probably has to be mutable, of course. Okay. So now we maintain an array of such rectangles, right? So an array of such rectangles, and there we go. So here's the single rectangle. But what's interesting is that now I can push more than one in here, right? So let's actually push another one that moves in an opposite direction, but it moves from somewhere from the right side, right? And this one is going to be basically width minus rect width, right? Minus rect width. And all of that has to be probably as F32. There we go. So now we have two rectangles. And that should facilitate two rectangles. Hopefully, we'll see how it goes. There we go. One of them actually stuck, which is kind of funny, I think. We can sort of make it kind of unstuck. Maybe if we just yeah, let's actually put like an additional pixel in here just in case, just to see what's gonna happen. Right, and hopefully it will do something. Yeah, there we go. So now you can have two of them. So that's how we evolve our code base, right? So you see, what you saw right now is the development bottom up. I wasn't developing top down where I was sitting and thinking, oh, I will have several rectangles and stuff like that, so I need to have rectangle entity and how they're going to be, you know, interacting with each other and to have all of these interfaces. No, I just wrote the shittiest code possible, the simplest shittiest code that does the job, and then I factored out the right abstractions out of that mess, and now I can have several rectangles. So that's basically, you know, the best design in my opinion. not really the best. There are different ways you can actually design your code. So now, what do we have? So because sometimes top-down makes sense. Sometimes top-down makes sense. Top-down makes sense when you explain in concepts to people. In that case, top-down is actually a little bit better. So I don't really want to be dogmatic about that. So because I think there is a place for bottom-up and top-down development. So bottom-up development is great when you don't know what you're doing, right? So it's absolutely great, which is 99% of the time in programming, actually. So we as programmers quite rarely know what the fuck we're doing. So in that case, bottom-up development is quite useful, right? Because it allows you to first gather the information. Writing the messy code is basically the phase of gathering information of what's needed. And once you have something that is working, you know what's needed, and then you can group the abstractions out of that. Right, you can group the abstractions out of that. Where in case of a top-down, you already know what you're doing. You already went through the phase of gathering information, and you're just laying down the infrastructure, just showing how this infrastructure works. So, yeah, essentially. So bottom-up is when you don't know what you're doing, and top-down is when you do know what you're doing. Right, but these are kind of like a different situations. So right now here, I don't know what I'm doing. I'm just experimenting. Like I don't know in which direction the development will go, and that's why I'm doing bottom up. Right, I'm doing the mess, and then I'm cleaning up the mess. I'm just factoring out the mess into abstractions. So here, I think I factored out too much, right? Because I need to add a new rectangle when the rectangles sort of collide with the wall, right? So the rectangle collides with the wall, I need to sort of factor it out. So the question is, if we have a rectangle, right, and it hits the wall, we want to split it in half. So that means we need to remove it from the list. Right, we need to remove it from the list. We cannot remove it from the list while updating everything. What we can do, by the way, as we update, we can return a boolean indicating that there was a collision, right? So we can do that, at least. So essentially, collided is going to be false, and in here you can do collided true, and this one is also collided true, and then we just return collided. There we go. So and then while you update everything, you can check. If collided, you need to remove that rectangle from the list and add 2 new rectangles to the list, right? So that's what we need to do in here. In fact, that's precisely what we need to do. Interestingly, yeah, I think I'm starting to see in the future a little bit how we're going to be organizing all that. So we need to maintain the list of rectangles to remove. Right, so that's what we need. Mutable to remove, and this is going to be basically, you know, a list of maybe use sizes, basically indices within the rects to remove. Right, index within like this thing to remove, and let's actually put it like that. Maybe we're going to call it to split. Right, to split, and essentially every time. So we probably also need to enumerate this thing. Yeah, we need to enumerate this thing. Is there any way for me to use some sort of iterators or something like that? Or when I want to remove something from the vector, if I want to remove something from the vector, do I have to provide the index? So it has to be something like delete or something like remove. Okay, vec remove. Do we have remove? It is called, in fact, remove. Oh, there was a remove there. It's an index. Okay, so we have to operate on the level of indices. That's fine. That's totally fine. So that means I also need to enumerate this entire thing, right? Can I enumerate? Enumerate. So in here, we're probably going to have an index. So if you do rect update, what you want to do, you want to do to split push index. There we go. So we're sort of gathering the information of who needs to be split, right? And what's interesting is that I think updating of the velocity has to happen during the process of splitting, which means that we can just remove this entire thing. We just remove this entire thing and just leave it like that. What's interesting is that as soon as you collide it, you know for a fact that you need to split. So maybe we can even replace it like with true. As soon as you collide it with something, there's no point in, you know, continuing, you know, checking anything. You already split it, so whatever. So though to split everything accordingly, we need to know how we collide it, horizontally or vertically, right? So maybe, so now these two values is not enough. True and false. True means that collided, false means not collided. But this is not enough information. We also need to know how we collided. Did we collide it horizontally or vertically? So maybe we can introduce some sort of enumeration called collision, right? And it's going to be basically vertical or horizontal, right? Horizontal, and then we can return option that returns collision, right? So this is going to be collision. Here we can return some collision. So this is horizontal one, right? So this is the horizontal collision, and this one is collision vertical one, and this one is no collision whatsoever, right? There we go. So now the code that calls update knows what kind of collision has happened, right? So now it knows. And when we push this thing to split, we also want to know what kind of collision has happened. So that means here we also need to have something like collision, right? What kind of collision has happened in here? So we're going to push index. Oh, this one is rather interesting. So now we can use if let some collision, right? And then if it happened, we're going to be pushing this thing into the list itself. Okay, collision. There we go. So that's pretty cool. Okay. So I suppose I will have to do something like this for it to work. Right. So we're iterating through all of the rectangles, we're updating everything, and then collecting what needs to be split. Right, after that, we'll be iterating through the list of things that we're trying to split. So here we're going to have the index and type of the collision, right? Type of the collision in to split, and we're going to be iterating it like this. And here we're going to be actually performing the actual split, right? We're going to be performing actual split. When I delete a thing, I can actually get that thing from here, which is extremely convenient. So that means I can do something like rect, delete the index from here. That deletes the index and gives us this sort of index. And maybe now we can go ahead and introduce a function split that accepts self, right? Accepts self, the collision, basically the orientation by which you want to split, right? So something like collision, and returns a pair of new rectangles. Right, so I'm gonna actually mark it as to do. Right, so to split. Okay, so you get that, you delete this entire thing, and then, as you know, since you know the collision, right, you can do rect split. So you provide the collision, and you have the left one and the right one. And what you do with the left one and right one, you push them back into the list of the rectangles, left one and the right one. There we go. You see? So we iterate through all of the rectangles. We determine whether they collided or not, like how they collided horizontally or vertically, and we collect the list of things to split. Then we iterate through this list of things, and we deleting everything and generating new things again. Right, so let's actually see if this entire thing compiles without generating any bullshit. So it does not compile, so let's see. So this one has to be equals, and this is delete. So no method delete for vec rect. It's called remove. I keep confusing them. All right, so there we go. Index, so it is that. What else? Collision. And do we have anything else? Here is the collision, it's unused. So move occurs. There's nothing wrong with moving this thing inside of it, I think. Cannot move out of which is behind the shell. Oh, because it's a shell reference. Okay, so let's actually call it like this. Let's actually do derive, copy and clone. Right, so let's actually make it copyable and clonable. And everything seems to be compiled. Okay, cool. So the only thing we need to implement in here, we need to actually implement the split, right? So since we're starting to use collision not only as the orientation of the collision, but as orientation in general, maybe this thing has to be called orientation, right? Something like orientation. But orientation is such a long word, so I want to call it orient. I think it's going to be a little bit better. So now we have a thing that is orientation, how you collide it vertically or horizontally. Right, so let's actually try to recompile the entire thing and go through this entire stuff. So it's going to be collision, orient, boom, boom, boom. And it makes more sense, right? So orientation, horizontal or vertical. Orient, and this one is orient. Okay, so orient. Okay, cool. So now we need to split things accordingly. So let's do match on the orientation. So here we're gonna have, I want to actually do use orient and just like use everything out of it. Vertical, all right, and horizontal. It's gonna be horse. So in case of a vertical orientation, right, in case of a vertical orientation, so that means we actually collided like top or bottom, right? We collected top or bottom. So we can say that the rectangle's position, right? Rectangle's position is going to be pretty much the same. So we're going to have left and right. Right, and in here, rectangle, in terms of position, is going to be the same as the original one. So it's going to be x, self x, and y is going to be self y. Y, self y. But their velocities are going to be slightly different. Right, their velocities are going to be slightly different. So for the left one, y. I think dx is going to be the same as dx of the original one. By y is going to be the negative one. So that's the difference in here. So, but for the right one, dx is going to be negative, and y is going to be negative as well. So if you hit the wall, it's going to actually go in the opposite directions. Okay, that makes sense. That actually makes sense. So now you have left and right, and you can essentially return left and right. There we go. So that's how you would do that, I think. So, and the same for the horizontal one, right? The same for the horizontal one. But, oh yeah, I forgot the size. So the size should be a little bit smaller, I think. I think size should be a little bit smaller. So maybe we could introduce some sort of a factor, like twice as smaller, but to make it twice as smaller, we have to use floating point, which is kind of annoying, but I think we can do that. It shouldn't be, you know, that bad. So maybe 75, and it could be split reduce factor. That's what it's going to be. So it's going to be a global function, and it's applied to width and height, both width and height. Okay, so, and for the horizontal one, it's going to be pretty much the same. The direction is going to be the opposite, but here we're going to be using like minus this thing. Right, so let's go through the compilation errors. We're going to have quite a few of them. So let's go, split reduce factor. I'm going to put it in here, and it's going to be around 75. Right, around 75, and this one has to be explicitly casted to this stuff. Anything else we have in here? Oh, and that one has to be in fact F32. Yep, and this one has to be F32. Yesu, kawaii freaking desu. So since we implemented everything, so that's basically splitting. So every time this thing hits the wall, it's going to be split in two and it's going to become smaller. So it hits the wall, it will be two smaller things and so on and so forth. So since we are actually generating a lot of rectangles in here, I'm going to remove, the second one. And I think we forgot a very important thing in here. After we split everything, we have to remove it. We have to basically clean the vector, right? So we collected everything, we split everything, and we clean the entire thing. So that should be fine. All right, so look at me. So we have a simple engine. We have a simple entity system. Believe it or not, this is a simple entity system. And let's generate the video. Let's generate the final video. Oh shit, I think it blew up. Fuck. Okay, so the amount of components actually blew up. Yeah, so maybe, I don't know, man. So maybe we can reduce the amount of things that we can do in here. We definitely need to reduce the amount of rectangle because it grows exponentially, right? 2 to the power of n, right? And where n is the amount of hits of the wall, right? So it grows exponentially and just like blow up intensely. So it's not really great. One of the things we can do, like the easiest thing, is probably maybe reduce it to down 1 second. Maybe that will do the trick, and it actually generated well, but it wasn't as spectacular as I wanted to be. So let's generate 2 seconds. Yeah, and it just like goes to shit completely, and it probably won't ever finish because yeah, it will basically like kill my machine if I continue doing that. So we need a better solution, right? Because this shit grows exponentially. So one of the things we can do, we can only split when the we don't exceed a particular capacity, right? So if rect len, right, is smaller than rect capacity, only then we're trying to split things, right? If we still have this capacity, and the question is what's going to be the capacity, how many of them do we want to have? So the rect capacity could be something like I don't know, let's say maybe 100. 100 should be all right. Right, so this is a rect, and you cannot, okay. But I'm not modifying the length of the vector. It doesn't like that I'm trying to take the length of the vector while iterating this thing with mutable borrowing, but I'm never modifying the length of the vector, so it's a completely valid code that is rejected by borrow checker because it's dumb. Lindra Braga, thank you so much. Thank you so much for 9 months of Twitch Prime subscription. Thank you. I really appreciate that. So yeah, all right, it looks good. So let's see what's gonna happen. Oh shit, that's actually well, that was interesting. So it definitely blew up. But something went wrong because they started to tunnel through the thing. Right? So what I'm thinking is that we need like more robust way of updating this stuff, if you know what I'm talking about. More robust way of dating this stuff. So I think we could have something like tx, which is that what it's going to be, right? And then I'm going to replace x with y. All right, and interestingly enough, I think what we need to do in here is just basically plus tx, right? If plus tx results in splitting, we're not going to even update this entire thing, right? Then plus ty that, there we go. And only when we went through all of these checks, only then we're going to go ahead and update x and y, right? Okay. So what do we have in here? Let's see if it's going to actually produce anything. So maybe it's going to be, oh, and it's stuck. Okay, so that makes sense. So maybe we should actually start from around like 10, so it has an opportunity to at least do something. Otherwise, they're just not going anywhere, right? So otherwise, they're just not. And it's stuck. Why do they stuck though? That's very interesting. It's kind of works, but they basically stuck. Is that because the tunnel? It could be because the tunnel. So okay, so here's how we want to move this entire thing. Oh, I know why. Okay, I forgot the another thing. So it's going to be plus tx. So which probably means that I have to do something else in here. I think I'm going to call it n, right? And this one is going to be basically self x like this, right? And in here we're going to be checking new x and new y. This has to be y. Has to be y, and then if everything okay, we're gonna be basically reassigning the new value back to this entire stuff. There we go. So this is the new value. All right. So hopefully that will produce something. So whenever using foreground, maybe it's time to actually remove foreground. I don't think it's useful. Yeah, I think I know what's going on. This thing tries to split. I see. So this is really dumb because this thing tries to split. Yeah, and since we're not allowing this thing to split, it never updates itself. Okay, that makes sense. So this is a flaw in the logic of this entire stuff. Yeah. So I think what we have to do in here, all right, what we have to do in here is always update this kind of stuff. And when we are splitting, okay, so we need to completely change the logic of how we're splitting. Yeah, we need to completely change the logic of how we're splitting. And so I think split, because man, yeah, my brain actually a little bit tired, but I'm really, really close to this. Really, really close to making it look like I want it to look. What if... Okay, I have an idea. What if we do something like this? So we have two lists. We do split, and if you do split when you ran out of capacity, we're going to be deleting this entire thing. I think that's going to be actually kind of cool. I really like this idea. So let's introduce to delete. To delete, and this to delete is going to be just use size. Right. So yep, we're pushing it here, and then for index into, can you delete several of them simultaneously? maybe to delete, iterating this entire thing, and essentially it's going to be rects remove index, right? So it's not going to even try to do anything. To delete clear. So because of that reduction, I think reduction factor has to be a little bit bigger so they don't disappear very, very fast. So I think that's going to be a better way. Okay, so something removal index should be, oh fuck, okay. Because this thing invalidates the indices of this one. So maybe the logic of deleting things should be not here. It shouldn't be here. I have an idea. So essentially, if you try to remove, right? If you try to remove this entire thing, it's going to be something like, so we're always going to try to split things, right? We're always going to try to split things. So we remove the entire thing, and interesting enough, how does it work? So we go to the indices and we actually have to handle them in an opposite order. We have to, yeah. Why don't I do that in the opposite order? So I guess that's what I need to do first. So can I just do like a reverse out of that? Right, so we take things to split, right? Because they're in this order, because it can invalidate everything. Okay, so we inverse that and we handle that in opposite order. But here is the interesting thing. We're only gonna push that if rect's len is less than rect's capacity. Only then we're pushing this entire thing, and then the same goes to here. Okay, I think that could be the feasible solution. I think that could be a feasible solution. Let's give it a try. So yeah, so that thing is not useful anymore, and hopefully that thing is going to be working. Yo! That's precisely what I wanted. That is precisely what I wanted. That is so cool. So, what do you guys think? So, you know, I think it would be even better to, I don't know, have FreeUni subscribed at tier 1. Thank you so much for 2 months of tier 1 subscription. Thank you. Okay, so can we just try to do something like this, right? So, and I need to regenerate that. So, and for some reason it's stuck, right? And it generated like a lot of different weird shit. So let's see how it's gonna go. Yeah, it keeps generating some stuff. So because it hits the corner, and in the corner it just generates a lot of stuff. So maybe we could offset the entire thing like that. I'm just trying to make it like, as soon as it hits the corner, it actually creates the situation when it creates like a generator of these things, which is not ideal in my opinion. Yeah, you see, it's just like, it's kind of weird. Also, when the rectangles hit a particular size, right, maybe we should never create them because they're too small, right? Right. So it's gonna be something like 13. Rectangle factor, yeah, that's basically what's going on here. So maybe too small rectangles should never be created, right? So they should be eliminated from the entire existence. Why does it do that? I don't know, man. Like I don't want it to hit the corner because it's like creates that. I probably can prevent the corner situation somehow, maybe. Oh, I even know how it creates. Okay, that's way better. That looks way better actually, because it never hits the corner, right? So when we split, we actually create things in opposite directions, right? This is such a cool thing to play with. I really like that. Okay, so maybe we should have a situation when the orientation is sort of like both, if you know what I'm talking about. It's just like both of them. In that case, what we have to do, we probably shouldn't split, but I'm not sure. I'm not really sure. As soon as you hit the corner, it's just like, it creates this generator. I would never thought about it actually. I really want to code this simulation outside of video rendering, just on its own in real time, because I think it's a very interesting simulation to observe. Never thought about it. Okay, so FPS is 16 here. What if I actually have like a 4 seconds? Okay, so it's a very interesting simulation on its own. Yeah, that's for sure. I like that. The video that it generated, it's 330 megabytes. 330 megabytes. Okay, so I'm gonna do ffmpeg. So the input is gonna be output YFM and output MP4. Well, I mean, of course. I should have not closed that. So, and if I play that with mPlayer, okay, so let's actually see how Discord will react to that. Okay. Okay. It's actually so cool. I really like that. This is such a cool concept. I really want to. It feels like some sort of I don't know, something similar to Game of Life with generators and stuff like that. So there's something mathematical about this system, and it's like generates this shit. And it's so cool. What if they were perfectly squared? Right. So one of the things that kind of bothers me is that they are not perfectly squared. So maybe we could make them perfectly squared, if you know what I'm talking about. So this could be one of the things we could do. What I'm doing is completely outside of the scope of like simple video format. So it's more of like a mathematical thing to play with. All right. Do I want to do anything with the corner situation? I'm not really sure if I want to do anything with the corner situation. Maybe it's like a part of the system, right? It could be just part of the system. One thing I want to do is, I guess, being like not including too small rectangles, so to have some sort of a threshold. Right, and to have some sort of a threshold, we can have something like area, right? So area of self, and it's gonna return f32, right? And essentially what it will do just self w self h, right? And if a particular thing, so rect is less than that, and left area is less than rect area threshold, only then we're adding this entire thing in there, right? Only then we're adding this entire thing in there, right? And we will have to define what is the rect area threshold, right? So what's going to be that? So we have a lot of constants related to the rectangles, f32. So the area, let's say, is going to be like around 10. Maybe we can adjust that stuff. Okay. So what do we have in here? So this one is not needed. I do agree with that. So left is actually right. Oh, this is actually pretty cool. So it actually caught a bug. I'll give it that. I'll give it that. Okay, so apparently, yeah, I think it has to be reversed. I think it has to be reversed. Okay, so at some point they're gonna start disappearing over time. They're gonna start disappearing. But we didn't actually simulate long enough to see how they disappear. So let's actually try to simulate 10 seconds of this entire thing. We know that it's not going to exponentially blow up. Let's just generate 10 seconds of this stuff. It generates with a pretty decent speed, I would say. At some point, yeah, so at some point it's going to actually speed up. Because they're dying. Yeah, there we go. So at some point it just speeds up because they're dying. So there was like a curve. So at some point the amount of entities like grew to the 100 and it had a hard time rendering them, and then they started to die out. So, and we can see how it looks now. Yeah. So that's basically what's going on here. So it's 10 seconds of the simulations. Okay, so looks like, yeah, what about 20 seconds of the simulation? So I want to like wait until they completely die out. Okay, it's having a hard time, and then it's gonna speed up. No graphical libraries, no nothing, no dependencies, by the way. It's just like a pure code. Nothing special, just a pure code. That's what I like about this shit. It's so cool. Like, this is like truly recreational programming, in my opinion. Right, so you don't bother yourself with fighting with build systems, with dependencies and stuff like that. You just code. It's just like a pure imagination. Pure imagination. That's what it is. At which moment it actually completely died out? So let's actually take a look. I want to do VLC. Okay. Yeah, 16, around 16 seconds. I wanted to generate sound as well. I just realized. Yep. Roughly, more or less. Okay, so ffmpeg, let's regenerate the thing. That's a lot of frames. It's actually rendering at 30 FPS, but we generate it at 60 FPS. So, all right, and so the final thing in here is this one. Oh my god, VLC. Yeah, there we go. That's cool. That's very, very cool. So, and if I put that into the final thing, so this one is a bit longer, 2 megabytes. Maybe it's FPS per second, maybe. God, this is so cool. This is like Twitter worthy. I wonder if I can post that on Twitter. So Twitter actually always been pretty bitchy about the format of the videos. I'm not even sure if it will support that. Every time I try to tweet a video, it's just like a pain in the ass, but I don't know. Okay, so I'm going to commit whatever we have already. Let me see. So this is publish fixed chorus. Generate cool rect animation. Cool rect animation. I'm gonna push that right into the repo. I suppose I'm done with animate something, and I would like to generate some sounds, but I already wasted 4 hours on generating the imagery, right? So this thing took quite a bit some time because we had bugs in the implementations and stuff like that, in the formula especially, right? So yeah, this is the correct formula. This is the correct formula. So the original idea of this series was to explore a simple video format that you can use for debugging purposes. Essentially, without any special third-party dependencies, can you generate a video file that is playable in common video players? So the simple format that I found is this one, which is like MPEG, what is it? UV for MPEG2, which is rather simple for a video format. It is extremely simple, but it requires you to remember this formula, right? So you somehow have to remember that. And apart from that, that is it actually. So the rest of the generation is rather simple. Right, I wish you just didn't have to remember this, and that would be a perfect format, but unfortunately I couldn't find a simpler format than this. So I wish there was like specifically video format for debugging and stuff like that, but it is what it is, and it isn't what it isn't. But at least we generated pretty cool animations, so that was fun. Maybe at some point I'm gonna just generate that with OpenGL and just play more with this kind of stuff, because it's kind of lame to wait, you know, while it renders everything. So I want to update this kind of animation like in real time. So yeah, maybe at some point we're gonna do that as well. We're gonna just code this thing without any of this bullshit. So in terms of the source code, you can find this thing in GitHub if you're interested. So it's available in here, and for people who's watching on YouTube, you can find this thing in the description as well. So yeah. I wish I had time to generate the sounds, but I didn't generate the sound because I didn't really have time for that. So it is what it is, and it isn't what it isn't. So that's it for today, boys and girls. That's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all next time. I don't know when, I don't know where. So yeah, see you all next time. Maybe I'll come up with something more interesting next time. We'll see, we'll see. I'm constantly searching for interesting topics to explore in the stream. Love you.